Hello there and welcome to our channel. The lights are low, the thoughts are soft, and tonight we're doing something a little different. We're imagining a world where the ground beneath us no longer turns, a world where the earth simply stops spinning. Now, I know that sounds like the beginning of a science fiction movie, the kind where cities crumble and satellites fall out of the sky. But here in our quiet corner of the internet, we don't shout about disasters. We take our time, we ask strange questions, we look at them from every angle, and if they lead us to unexpected places, we follow. So tonight, let's set aside the usual rush of spinning days and ticking clocks. Let's pause literally and ask, what if the Earth just stopped turning? Of course it hasn't, not yet anyway. Your feet are still firmly planted on a planet that's rotating at over 1,600 kilometers an hour at the equator, even if it doesn't feel like it. And that's part of what makes this thought experiment so quietly strange. We don't feel the spin, we don't hear it, we don't see it, but it shapes almost everything in our daily lives, from the way wind moves across the ocean to how long the sun stays in the sky. It decides the rhythm of light and darkness, the timing of our meals, even the habits of our pets who somehow know when it's time for dinner, even before the fridge door opens. But what if, for some unknown reason, it all came to a halt? Maybe it's sudden. Maybe something immense and mysterious applies a force and slows the Earth to a stop. Or maybe it happens gradually over years or centuries, so slowly that it's almost imperceptible at first. The truth is, physics doesn't really allow for either without some serious consequences. But tonight isn't about what's likely. It's about what would follow if the unlikely somehow became real. We'll start with the basics. Right now, as you listen, the planet is rotating from west to east. That's why the sun appears to rise in the east and set in the west. That rotation gives us day and night, the gentle alternation of light and darkness that humans have lived with for as long as we've had eyes to see it. If the Earth stopped spinning, that cycle would change dramatically. Instead of 24 hours of spinning every day, one full rotation would now take a year. The sun would rise slowly, inching across the sky over the course of months. One side of the planet would bake under constant daylight, while the other would be left in an extended freezing night. Temperatures would swing wildly. Crops wouldn't grow the same way, animals would struggle to adapt, and humans, well, we'd have to rethink almost everything. But we'll get to that. There's a lot to explore before we worry about sunrises and seasons, because the moment the Earth stops spinning, a lot of things happen very, very quickly. First, there's inertia. It's a simple concept, but a powerful one. When something is in motion, it wants to stay in motion unless something forces it to stop. You felt it in a car that suddenly brakes. Your body keeps moving forward just for a moment. Now imagine that feeling, but for everything on Earth. As the planet spins, so does everything on it. The ground, the air, the oceans, the buildings. If the Earth came to a sudden stop, an immediate, complete halt, that inertia would become catastrophic. The atmosphere wouldn't stop right away. Neither would the oceans or the objects not bolted down. Cars, trees, even the surface water in lakes and seas. All of it would continue moving at over 1,000 kilometers an hour. The result would be, frankly, devastating. Winds would race across the surface like invisible tsunamis. Anything not fixed to the bedrock would be flung eastward. Entire forests could be leveled. Buildings could collapse from the force of the air alone, not because of an explosion or earthquake, but because the world simply let go of its spin. The oceans would slosh sideways, pulled by their own momentum, creating walls of water taller than any we've ever seen. Coastlines would vanish. Lands would be drowned. It wouldn't be an apocalypse in fire, but in motion, or more accurately, in the sudden loss of motion. Of course, we've said this is a thought experiment, a moment to imagine, not panic. So let's say it didn't happen instantly. Let's say the planet slowed gradually over years or decades, giving everything a chance to adapt. The air currents would still shift, The oceans would still move, but not as violently. Instead of one enormous disaster, we'd face a slow unraveling, one system at a time, failing to cope with the new conditions. You might not notice it at first. Maybe the days start getting longer, not noticeably, just by a few seconds, then a few minutes, then half an hour. Your morning alarm still goes off. Your coffee still tastes the same, but the sun rises later and later each week. Before long, the difference becomes hard to ignore. Suddenly, it's daylight for most of what used to be the night. And then it's light all day and all night for weeks, then months. Meanwhile, on the other side of the world, the sun hasn't come up in ages. Entire cities are locked in a deepening twilight, then complete darkness. Temperatures plummet, plants struggle. Electricity demands skyrocketed just to keep people warm. And eventually, no amount of insulation or artificial lighting makes up for the loss of the sun. If you're on the daytime side, it's not much better. The sun climbs higher each week, and the air grows hotter, drier. Water evaporates from reservoirs. Crops wilt. People seek shelter underground or inside reflective structures, anything to escape the glare. If you've ever touched a car dashboard in summer, imagine that sensation stretching on for months. Not just heat, but a kind of oppressive, inescapable presence. Sunlight without pause, but it wouldn't just be sunlight causing trouble. The lack of rotation would mean changes to how our atmosphere moves. The jet streams, the fast-flowing rivers of air high above the surface, are driven in part by the Earth's spin. Without it, those streams would falter, then collapse. Storms would change in shape and size. Hurricanes, for example, rely on the spinning of the Earth to form their distinctive spirals. Without that rotation, storms might still occur, but their patterns would be wildly different. Less rotation could mean more intense vertical motion, stronger updrafts perhaps, or larger, slower-moving weather systems that sit over regions for weeks instead of days. And then there's the question of the magnetic field. Our spinning molten iron core helps generate Earth's magnetic shield, the invisible barrier that protects us from cosmic radiation and solar particles. It's what makes compass needles point north, and what helps shield our atmosphere from being stripped away by the sun. If the Earth stops spinning, that protective field could weaken or vanish altogether. Not instantly, but gradually, as the dynamo effect inside the planet slows. Over time, this could lead to more radiation reaching the surface, especially near the equator. Northern lights might appear in unexpected places, but so might radiation burns and equipment failures. Still, life finds a way. That's what we've learned from centuries of watching nature adjust to changing conditions. Perhaps some species would thrive in the new patterns. Maybe desert plants would flourish on the sunward side, while deep-sea organisms move into frozen lakes on the dark side. Animals might migrate in new, stranger ways, seeking light, warmth, or food in directions that once made no sense. Humans, of course, would respond too. It's in our nature. We build, adapt, engineer. Cities might move toward the twilight zones, those narrow bands between scorching day and frozen night, where conditions are just barely livable. Technology would play a role, but so would instinct. We'd learn to farm in artificial environments, to generate power where sunlight is eternal or absent, to filter water from the air, or even create communities that travel with the slow-moving line between night and day. Some would stay put, of course. People always do, even when the skies stay dark and the power goes out and the cold creeps in. And others would chase the sun, living in caravans or ships, always moving westward with the light. It might sound lonely, but perhaps there would be a kind of peace in it. The quiet resilience of people who choose to live on a planet that no longer turns, but who refuse to give up on its possibilities. We haven't even touched on how calendars would change or how timekeeping would need to be redefined. Because if the Earth no longer spins, what is a day? How do we divide time when the sun no longer rises and sets on a schedule we understand? Maybe we'd go back to something older, measuring time by seasons or by biological rhythms. Maybe we'd invent entirely new systems. Digital calendars tied to artificial cycles glowing softly on screens that don't care where the sun is in the sky. But that's for another part of this journey. For now, let's just linger in this first strange moment. The moment the world stops turning and everything starts to change. If you've ever fallen asleep to the sound of a ceiling fan or the gentle hum of a train in motion, you might already understand, at least a little, the comfort of something quietly spinning. The Earth's rotation is invisible to us, but it's part of that background rhythm we all live with. It's there in the rising light through your window. It's there when shadows shift over the hours, and while you can't hear it or feel it directly, your body has always known it was there. Even if we rarely think about it, that rotation plays a central role in how our days unfold. It gives us a 24-hour cycle. It divides time into measurable chunks that our biology is synchronized with over countless generations. Our sleep, hunger, attention, even mood, they all ride the rhythm of spinning Earth. Take that away, and the body isn't just confused. It starts looking for something it can't quite name anymore. This isn't just about sunrise and sunset. The turning of the planet gives us a dependable cadence, a sense of when to work and when to rest. Light and darkness help regulate melatonin, the hormone that signals sleep. When it's dark, levels rise. When the sun comes up, they fall. It's a pattern so deeply embedded that even in places without clocks, people still tend to sleep and wake on roughly the same cycle. It's not just a habit, it's biology. So what happens when the Earth stops turning? Suddenly, the light doesn't change every few hours. It doesn't arrive at dawn and retreat at dusk. On one side of the planet, it simply stays for days, then weeks, then months. The sky glows, but never dims. And on the other, the darkness never ends. The sun hasn't risen in weeks, and there's no sign it will anytime soon. The human brain struggles with this. When the environment doesn't match the internal clock, that circadian rhythm starts to drift. Without cues, what scientists call zeitgebers, like sunlight, meal times, or social schedules, the body begins to fall out of step. People might find themselves awake at odd hours, sleeping during what feels like the middle of the day, feeling alert in the middle of the night, though night has lasted for weeks. In places that are locked in constant daylight, insomnia would become common, not because of stress or worry, but because the brain no longer knows when to rest. Light pours in through windows, even at midnight. Street lamps don't matter anymore. People hang blackout curtains, wear sleep masks, try to simulate a darkness that no longer comes on its own. Sleep hygiene becomes not just a lifestyle tip, but a survival strategy. On the other side of the planet, the problem reverses. Months of night start to feel less like rest and more like a weight. Without daylight, depression rates could rise, vitamin D levels would plummet. Even with artificial lights, the absence of the sun feels different. People might go for weeks without seeing their shadow. The world becomes enclosed, dim and heavy. Time loses its familiar punctuation. Everything feels like the same long moment, stretched too thin. This affects more than sleep. Digestion works differently when circadian rhythms are disrupted. Hunger becomes unpredictable. Metabolism shifts. Hormones get out of sync. Concentration suffers. Decision-making gets slower. Immune function declines. Even the way our bodies process medication can change, depending on when it's taken in the cycle of light and dark. Research from places that already experience extended daylight or darkness, like parts of Norway or Antarctica, give us a glimpse of what this might look like. In polar winters, people report fatigue, irritability, confusion about time. They rely on routines and artificial structure to stay grounded. Schools and workplaces run on normal hours, even if it's pitch black at noon. But these are seasonal changes. They come and go. In a world where the spin is stopped, the change doesn't end. It's permanent. And it's not just humans. Plants rely on the rotation of the planet too. They open and close their leaves with the sun. They use day length to time flowering, fruiting, and dormancy. Without regular days and nights, some species would fail to grow altogether. Others might survive, but in strange patterns, blooming out of season, growing in stunted forms, or simply going dormant for good. Animals also struggle when day and night disappear. Migratory birds rely on daylight cues for navigation. Insects use the sun's position to orient their movement. Nocturnal creatures depend on darkness for safety and hunting. In a world where the sun never sets or never rises, their patterns would unravel. Predators might hunt endlessly. Prey might lose their hiding hours. The balance between species could shift in unpredictable ways. Insects like bees and moths are especially sensitive. Bees, for example, use sunlight to locate flowers and return to their hives. Without a sun that moves their dance, the way they communicate directions would become meaningless. They might get lost, hives could collapse, pollination rates would drop. Entire ecosystems might shift, not because of temperature or rainfall, but because the sun no longer tells time. Some animals might adapt over generations. Evolution would favor traits suited to perpetual light or dark. Perhaps eyes would grow larger or smaller. Circadian systems would change, but adaptation takes time, and for many species, the shift would come too fast. Extinction isn't always dramatic. Sometimes it's just the slow quiet of a pattern no longer supported. For humans, it might take longer to notice some of these changes. At first, we'd try to maintain the same schedules. We'd set alarms, keep clocks running, insist on office hours and dinner times, but gradually the mismatch between our bodies and the unmoving sky would take a toll. Sleep clinics would see a surge in patients. Companies might offer light therapy rooms. Schools might adjust to chronotypes, letting students work when they're naturally alert instead of enforcing a universal morning bell. In places of permanent daylight, people might live underground or in heavily shielded buildings, emerging only at certain hours. The sun becomes something to be avoided, not chased. In the long night regions, entire cities might be bathed in artificial daylight just to keep people functioning. Not because it's bright, but because it's structured. Because the brain needs rhythm, even if it has to be invented. Travel becomes stranger. Cross into the twilight zone, the narrow region where light and dark still exist in rotation, and your body doesn't know what to do. Your internal clock is one thing, the sky is another. Time zones become less about longitude and more about light levels. Cities might redefine their clocks entirely, syncing not with the prime meridian, but with the position of the terminator, the line between light and dark that now crawls across the surface once a year. Over time, culture would adapt too. Songs and stories about sunrise and sunset might become nostalgic, set in a past that no longer repeats. Rituals tied to dawn or dusk would need new meaning. Maybe new holidays would emerge tied to the slow crawl of the sun across the sky. New ways of marking time. New ways of finding rhythm when nature no longer provides it automatically. And always underneath it all, the body keeps trying to make sense of it. The cells keep ticking. The brain keeps searching for patterns. The body is still running its ancient program, written in the language of a spinning planet. Only now that planet is silent. But the story doesn't stop there. Because when the planet stops spinning, it doesn't just change time and sleep and sunlight. It changes the way the sky looks. It changes how air moves. And soon it starts changing where the oceans belong. There's something unsettling about the idea of stillness on a scale this large. The Earth, after all, has never truly stopped, not in any way that matters to us. It's always turning, always moving under our feet, even if that motion is invisible, silent, constant. We live our entire lives on a planet that spins us eastward, whether we notice it or not. And yet, in this imagined scenario, the question becomes simple and strange. What if one day the spin just stopped? Not slowed, not paused, not staggered through an extended wobble, just stopped. It's a question that pulls at the seams of everything we take for granted. Because if the Earth were to hit the cosmic brake, so to speak, and stop rotating, the effects wouldn't be confined to calendars or weather patterns. They'd be embedded in physics itself. Motion doesn't disappear without consequence. Not at this scale. Everything on the surface of the planet is currently in motion. That includes the oceans, the clouds, the people, the animals, the tectonic plates, the entire atmosphere. It's all moving with the spin of the Earth. And it's not a gentle movement. At the equator, that spin moves at about 1,670 kilometers. That's roughly 1,000 kilometers, vast enough to carry you across the length of a country in less than an hour if you weren't attached to the ground. But you are. We all are. So is everything else. Now imagine that motion ending, not easing down over millions of years like it might in some very slow natural process, but halting abruptly, hitting the brakes, so to speak, in a way no planet was designed to do. In that moment, inertia, the same force that pushes your body forward in a sudden car stop, becomes a global event. The surface stops, but the air doesn't. Neither do the oceans, and everything not anchored deep into the crust keeps moving because nothing told it to stop. Buildings would collapse, not from earthquakes, but from sheer lateral force. Glass would shatter, not from vibration, but from the pressure of air slamming into structures at hundreds of kilometers per hour. Trees would fall eastward, entire forests flattened, not by axes or storms, but by the motion of the wind still trying to move, while the ground below it no longer does. The oceans would keep moving too. The water at the equator especially has momentum that would carry it eastward, piling up against coastlines, flooding inland, carving new paths into cities and valleys. Low-lying areas could disappear beneath water that no longer follows tidal rules. The seas would slosh like an unbalanced bowl held suddenly still, and that's just what we'd see from the surface. Air pressure systems would be thrown into chaos. The Coriolis effect, that gentle twist in air and ocean currents caused by Earth's rotation, would vanish. Jet streams would collapse. Storm systems that once curled and drifted across continents would lose their shape. Hurricanes, which rely on rotation to spin, might cease to form altogether, or take on entirely different dynamics we can't easily predict. Satellites orbiting above would notice it too. Their orbits rely on the Earth's shape and spin. Without rotation, the planet's equatorial bulge would begin to smooth out over time, and that change in mass distribution could alter gravitational pull just enough to disrupt the carefully calculated paths of satellites and space stations. Communication networks, GPS, weather tracking systems, all of it could falter, then fail if not corrected. The redistribution of the planet shape wouldn't happen overnight, but the process would begin the moment the spin stopped. The Earth is slightly wider at the equator than at the poles because of centrifugal force, the outward pull of the planet. Take away the spin and that force disappears. Gravity starts pulling everything back toward a perfect sphere. Oceans would migrate toward the poles drawn by the shifting mass. What we know as equatorial shorelines could drain, exposing vast stretches of seafloor, while polar regions become inundated. Mountains might rise or fall slightly, not from tectonic action, but from the rebalancing of pressure. Continental plates might shift subtly. The distribution of weight on the crust changes, and the Earth calls and groans in response, trying to find a new equilibrium. Some areas would see increased seismic activity, not just aftershocks, but entirely new stress fractures opening where the crust wasn't prepared for the change. It wouldn't just be environmental. Society is built on assumptions that the ground stays where it is, the oceans stay at sea level, and the air behaves in predictable ways. Transportation networks, agriculture, urban planning, they all depend on the planet's quiet spin. We don't plan our buildings to withstand winds of 500 km/h, or plan cities with the expectation that the ocean might start heading toward the center of the continent. Most people don't live at high elevations, and most of the world's population lives near coastlines. That puts billions of people in harm's way in one way or another. If the stop were gradual, it might be survivable depending on how slow the deceleration was. A tiny reduction in speed each year over thousands or millions of years might allow the atmosphere to adjust, oceans to redistribute slowly, biological rhythms to shift. In that scenario, human civilization might keep up, reinventing itself step by step. Coastal cities would move inland, power grids would reorient, travel might become more localized. New cultural norms might emerge to deal with extended day and night cycles. But if it was sudden, there would be no time to adapt. In a purely mechanical sense, the sheer energy required to stop the rotation of the Earth is hard to grasp. It's immense. The planet's rotational kinetic energy is estimated at about 2 porententine, or 10 to 29 joules. To bring that to zero would take more force than anything we've ever encountered, more than all the nuclear weapons ever built, more than any collision we could imagine, short of a planet-sized impact. So, the only likely ways it could happen if we suspend disbelief are rather by some unknown cosmic force or advanced manipulation of planetary-scale physics, far beyond anything humans have attempted. We're firmly in the territory of fiction now. But still, it's useful to consider because when we understand what keeps our planet in balance, we understand how fragile that balance really is. Even if the Earth never stops spinning, and it likely won't, at least not for billions of years, the very idea reveals how dependent we are on its motion. We don't need to feel it to be shaped by it. We don't need to hear the hum of the turning Earth to live by its rhythm. We're creatures of a spinning world in ways we rarely stop to consider. And if that world ever stood still, the noise left behind wouldn't come from the sky or the ground, but from everything still moving when it no longer should. The wind, the water, the world caught off guard by stillness. But movement doesn't always come from speed. Sometimes it comes from light. And if the Earth stopped spinning, light would behave differently too. On most days, the sky is something we look at without thinking. It tells us the time, even when we don't check a clock. It reflects our routines, the way shadows move through a room, the way the color shifts between morning and evening. These are signals we've learned to read without effort. They're comforting in their regularity, but that comfort, like so many things, depends on the Earth turning beneath our feet. Take away the rotation, and the sky doesn't just change. It forgets how to behave. Right now, the movement we see overhead, the drifting of clouds, the path of the sun, the slow crawl of the stars across a night sky, all of that is an illusion created by our planet spinning. The sun doesn't rise or set because it's moving around us. We spin into its light and then away again. It's a steady rhythm we've lived with for as long as we've existed. Animals navigate by it, plants track it, humans build entire schedules around it. But if the Earth were to stop spinning, all of that would shift. Let's start with the sun. Instead of appearing each day in the east and gliding across the sky toward the west, the sun would seem to freeze in place for a while. It would slow its climb, then hover at a fixed point in the sky for longer and longer periods. Eventually, it would begin its journey across the sky, not over the course of a single day, but over a year. A sunrise wouldn't take minutes, it would take weeks. The sun would slowly peak over the horizon, inching upward by a fraction of a degree each day. Mornings wouldn't be moments, they'd be drawn out like seasons. It might take months for the sun to reach its highest point in the sky, and then just as slowly, it would begin to descend. On the side of the planet facing the sun, that long day would stretch on, relentless. For weeks, the light would intensify. Shadows would shrink and shift gradually, the warmth building until it's no longer warmth, but oppressive heat. Windows would remain covered most of the time. People might move outdoors only at dawn and dusk, if those times still exist in any meaningful way. Overhead, the sun wouldn't travel visibly through the sky each hour. It would just hang there, barely changing from day to day. On the dark side of the planet, the opposite would happen. The sun would seem lost, never appearing, never moving. People would wait for a glow on the horizon that doesn't come. Weeks would pass in blackness. The stars would remain in the same places in the sky, frozen like illustrations in a book. Constellations wouldn't shift during the night. There would be no nightly motion to track. Everything above would be still. The moon, too, would appear different. Our moon already has a locked rotation. It shows us the same face all the time. But from our point of view, it moves across the sky, pulled by the spinning of the Earth. Without that spin, its behavior would become unfamiliar. It would hang in the same place in the sky for long stretches. It would rise and set based only on the slow orbit between it and the sun, not by any daily motion of the planet. And depending on where you stood, you might not see it move at all for weeks at a time. Astronomy, as we know it, would lose its practical usefulness. Sundials would be relics. Telescopes might be repointed at objects that no longer transit the sky. For amateur stargazers, the sky might feel empty, not because there's less to see, but because the show has stopped. No more watching planets rise or the Milky Way arc overhead. Everything just stays. Even for those not looking up, the effect would be noticeable in small, strange ways. You'd notice that streetlights come on at odd times, not because the timer is broken, but because the daylight doesn't follow a schedule anymore. Time zones would lose their meaning. A city on the edge of perpetual night might share a clock with a city in full daylight, but the sky would tell two completely different stories. And then there's the color of the sky itself. The blue sky we see during the day is caused by a process called scattering. Sunlight enters the atmosphere and gets scattered by air molecules. Shorter blue wavelengths scatter more than reds and oranges, so the sky appears blue. At sunrise and sunset, the sun's angle means the light travels through more of the atmosphere, scattering more of the blue and leaving us with those soft pinks and oranges near the horizon. But if the sun barely moves, those colors don't come and go in a few minutes. They stretch out for days. Imagine a week-long sunrise, the sky tinged with gold and orange for entire mornings, or an evening that glows crimson for days before the sun finally disappears. It might be beautiful, but it wouldn't be familiar. And beauty stretched too long becomes exhausting. Clouds, too, would behave differently. They're shaped by the movement of air, which is shaped by the rotation of the planet. Right now, clouds shift and evolve quickly. They form, stretch, collapse, all while being carried along by winds that circle the globe. Those winds are partly the result of the planet's spin. Without it, everything slows. Clouds might become larger, more stationary. Storms could linger in place for far longer than we're used to, dropping rain for weeks on the same region or refusing to move out of an area that desperately needs sun. Weather forecasting, already difficult, becomes nearly impossible. The patterns that once repeated every season are gone. The sky doesn't follow the old rules. A cloudless sky might persist for a month, baking the land below it, or a dense cloud system might park over a region, blotting out what little daylight remains, turning day into a strange, glowing dusk. At high altitudes, jet contrails would hang in place much longer. Right now, the wind disperses them in minutes or hours. But in a slower atmosphere, those trails might stretch across the sky and stay there like scars, artificial linear clouds that mark the path of something long gone. They tell stories of movement in a sky that no longer moves. And all of this The sun that stops rising, the stars that stop drifting, the clouds that stop crossing overhead, it would have an effect not just on ecosystems, but on psychology. Humans are pattern-seeking by nature. We rely on motion, on cycles, on the reliable choreography of the sky to anchor our sense of time. Even if we don't consciously track it, we notice when things are off. In a sky that forgot to move, people might feel untethered, disoriented even when standing still, unable to track progress through the day. Not because they're lost, but because the sky no longer provides context. It's like trying to tell time in a room with no clocks, no windows, no rhythm. Even when we invent new systems, lights on timers, structured schedules, artificial cues, they're replacements, not equivalents. For cultures that once told stories through stars, passed down knowledge through the shifting heavens, there might be a deep sense of loss. Oral traditions that rely on seasonal constellations or lunar cycles would fade. Festivals tied to solstices or equinoxes would lose their anchors. Myths about rising suns and wandering moons would become historical, not experiential. The sky becomes less a living presence and more of a ceiling, painted, unmoving, and strange. But this isn't a total eraser of meaning. It's a transformation. Some would learn to track the sun's progress through a much longer lens. People might build instruments to mark the sun's slow crawl across the sky, observing not hours, but weeks. Temples might be built that catch a single ray of light only once a year. New rituals might form to celebrate the turning point of a year-long day or the brief return of twilight. Calendars might stretch and warp to match the sky's new schedule, shaped by patience instead of speed. New meaning doesn't always come easily, but it comes. Even in a sky that has stopped moving, people will find something to watch, something to follow. Even if it takes a year for the sun to cross the sky, someone will be there to mark its passing. And while the sky above us grows quiet, the world below it keeps changing. Because with no spin to stir it, the atmosphere begins to behave differently. Air no longer knows how to travel the way it used to. Winds lose their familiar rhythm, and eventually those gentle breezes turn into something far more extreme. The side of the planet facing the sun doesn't notice the change all at once. The light still pours in, the sky still glows. Mornings still look like mornings at first, but it doesn't take long before something starts to feel off. Maybe it's the angle of the light that lingers too long. Maybe it's the heat that doesn't quite ease off the way it should. Maybe it's the moment someone looks at the clock and then at the horizon and realizes the sun hasn't moved since breakfast. At first, the change feels subtle. The sun doesn't race across the sky like it used to. It drifts slowly, like it's unsure of its direction. A few days pass, then a week, and still it hasn't made much progress. The shadows that stretch long in the morning hold their shape until late afternoon. The soft glow of the early day just keeps going and going. People start to talk about it, of course. They wonder if it's a fluke, if something's wrong with the atmosphere, if it's some strange seasonal illusion. The scientists already know better. They've been watching the data change for months. The planet has slowed, not by much at first, but enough. And now the rotation has come to a halt. On the sunward side of the Earth, that means only one thing. Day has arrived, and it's not going anywhere. In the first few weeks, life tries to carry on. Schedules stay the same. Work begins at 9, children go to school, people eat dinner under daylight that never dims. Some enjoy it. Extra sunlight means more time outdoors. Shops stay open later. Solar panels work overtime. The sky stays a deep, steady blue. At night, which no longer comes, streetlights begin to seem unnecessary. But the novelty fades quickly. The longer the sun stays up, the more everything starts to feel stretched. The warmth becomes less pleasant. Buildings begin to heat from the inside out. Asphalt softens, tires wear faster. Electronics start to fail, not from overuse, but from constant exposure. crops that rely on temperature changes, on the cooler nights that help fruit form and sugars settle, begin to wither. Some plants bolt early, others don't flower at all. The rhythms they need have disappeared. Homes and businesses struggle to cool themselves. Air conditioners run continuously. Energy grids start to show the strain. People sleep less. Animals become restless. The body doesn't know when to release melatonin. Sleep becomes shallow, inconsistent. Tempers shorten. Fatigue becomes normal. Night owls lose their anchor. Early birds forget what early means. Temperatures continue to climb. The sun no longer skims the sky. It parks itself there. The heat becomes constant. Clouds thin out, pulled apart by the warming air, leaving less shade than before. Lakes begin to evaporate. Rivers shrink. Drinking water becomes harder to find. Urban heat islands, the warm zones around cities caused by concrete and steel, expand in size and intensity. Entire districts become unlivable. People retreat indoors. Windows are blacked out. Rooftops are painted white to reflect the sun. Cooling centers become community hubs, not just for the elderly or sick, but for anyone who can't afford to keep their home under 30 degrees. Public parks stay empty during the day. Children are told to play inside. Schools stagger their hours, holding classes in the cooler morning, if such a thing still exists. And all the while, the sun just stays there, watching. Gardening becomes a different activity. People begin growing plants in vertical farms, inside shipping containers, or converted basements. Hydroponic systems spread. Rooftop gardens are covered with shade cloth. Crops that once flourished outdoors are now dependent on artificial daylight cycles generated by lights and timers. The irony isn't lost on anyone. Sunlight, once the essential ingredient, has become something that needs managing. The agriculture industry shifts dramatically. Large-scale farming in open fields no longer works in many regions. Soil dries too fast. Pests don't retreat with the setting sun. Yields drop. Irrigation can't keep up. Food production moves toward controlled environments. Greenhouses with tinted glass. Underground grow rooms, climate-controlled towers. The demand for water grows. People use more of it to stay cool. Plants need more of it to survive. Livestock, already sensitive to heat, struggle to regulate their body temperatures. Dairy production drops. Meat animals eat less. Farmers begin shifting operations north toward areas once considered marginal. In time, the old agricultural centers are abandoned, not because the soil is bad, but because the sky no longer gives them rest. In the cities, life bends around the sun. Office buildings are redesigned with heat reflection in mind. Old skyscrapers, built for a time when night came regularly, become liabilities. Too hot, too inefficient, too vulnerable to power cuts. Newer construction trends downward, into the earth, where temperatures are more stable. Neighborhoods begin to resemble inverted towers, deep communal structures with layers of shared space, gardens and airflow systems that keep the worst of the heat above ground. Above them, the world continues to heat. Roadways begin to warp under the constant sun. Blacktop melts, softens, sticks. Cars are fitted with reflective panels and external cooling systems. Tires are made of different materials. Transit schedules adjust. Some cities run their trains and buses only during cooler twilight hours, which now last weeks, not minutes, before the sun climbs too high again. People's wardrobes change too. Light-colored fabrics, UV-resistant materials, head coverings, and temperature-regulating textiles become everyday wear. The fashion industry shifts to accommodate function over form. Shoes with cooling soles, clothing with built-in ventilation. Sunscreen with longer-lasting formulas becomes essential, not just for a trip to the beach, but for walking to work. Pets are walked at strange hours. Dogs wear protective booties. Cats don't go outside. Wildlife disappears from public view, seeking shade and burrows. Songbirds go quiet. Pollinators become scarce. People begin to notice that the mornings are no longer full of birdsong. The trees are quieter, the air feels still, even the wind changes. Without the spin of the earth to stir it, air doesn't circulate in familiar ways. Traditional wind patterns break down. Local winds still exist, driven by temperature differences between land and sea, or between shaded and sunlit areas. But the grand systems that once moved weather across continents are weaker now. That means fewer breezes. The air grows stagnant. Pollution lingers. Smog builds. Breathing becomes harder, especially in cities. Asthma rates climb. Outdoor exercise becomes a risk for many. In wealthier regions, people adapt through technology, filtered air systems, indoor climate control, wearable cooling packs, new forms of transportation, smart windows that darken automatically, food grown under LED lights, communities built underground or underwater, not because of a dystopian collapse, but because the surface has become inhospitable for long stretches. Elsewhere, the changes are harder to bear. Rural areas face migration pressures. Entire villages depopulate. Infrastructure buckles under the strain. Others harness underground reservoirs, using water as a thermal buffer. Caves are repurposed. Subway systems become shelters. School continues, but it looks different. Online classes during the daylight hours, which now exist only by artificial means. Children grow up learning about the sun like it's a concept, not a daily experience. Picture books show blue skies and sunsets they've never seen. Their sleep patterns are monitored by software. Their playtime is indoors. Their vitamin D comes in capsules. Some children are born into the night and have never seen the sun. They grow up with a different understanding of space. They don't think in terms of days and nights. They think in warm hours and cold hours. Their stories are full of firelight and deep shadows. They don't fear the dark. It's all they've ever known. Religion shifts too. Some traditions see the darkness as punishment. Others see it as a test. New rituals form around the return of light, simulated sunrises, festivals of heat and brightness. People gather to celebrate mock dawns, moments when lights are dimmed and then slowly raised in sequence, simulating the arc of the sun across the sky. It's not a replacement, but it helps. Artists adapt. Painters work in layered light, using projected color to mimic the lost gradient of dusk. Musicians compose in minor keys, echoing the slow rhythm of a world without shadows. Literature becomes more internal, focused on memory, on imagination, on the spaces we build in our heads. When the world outside no longer changes, the absence of sunlight doesn't just change survival, it changes meaning. It changes what people find beautiful, what they remember, what they long for. Nostalgia becomes sharper. Memories of warmth, of open windows, of sunlit breakfast become treasured and painful. People tell stories, not just to entertain, but to preserve. And still, the night goes on. Eventually, there's movement on the horizon. Not fast, not obvious, but the beginning of a shift. In some places, after months of blackness, a soft gray appears low in the sky. Just a line, like smoke. Then, over the course of weeks, it grows. The first light is dim, diffuse, scattered by atmospheric ice. But it's enough to cast shadows. People cry when they see it, not because it's bright, but because it's changed. Children who have never seen their shadow chase it. Animals emerge from dens, blinking in confusion. Birds sing out into the half-light. People hold hands and sit in silence, not speaking, just watching. And then the sun returns, not fully, not quickly, but undeniably. And for the other side of the world, the story is reversing. The long day is finally giving way to something cooler, quieter. They too begin to sense the shift, not all at once, but gradually. And the slow turning of the sky, long forgotten, begins again, sort of. But as the line between night and day begins to move, another force begins to stir. Not the light, but the wind. Because when warmth returns to a frozen world, it doesn't arrive gently. When you hear the word wind, you might think of something soft, a breeze across your face, the rustle of leaves, the distant rush through a narrow alleyway, maybe a storm at most, a strong gust, a window rattling branches, tapping glass. Something you've experienced, something that fits within the range of normal. But wind is just air in motion. And when the engine that guides that motion disappears, what comes next doesn't follow familiar rules. Earth's spin doesn't just shape day and night. It helps shape how the air above us moves. The planet turns, and the atmosphere turns with it. Not perfectly, but close. That difference, the lag between the moving surface and the air above, is what creates the complex weather systems we know. The Coriolis effect, the invisible hand that bends winds into spirals and pushes hurricanes into curves, depends on that motion. So do the trade winds, the jet streams, the polar vortices. These aren't just lines on a weather map. They're the arteries of our atmosphere, the structures that keep the planet's air circulating in a kind of controlled chaos. Take that spin away, and the structure collapses. In the early days of a stopped Earth, the atmosphere doesn't react immediately. Momentum keeps the air moving, even after the ground no longer does. But without a continuous push, those great rivers of air begin to break down. At first, it's just weakening. Jet streams slow, cyclones lose their curves. Weather patterns linger longer than expected, but soon, imbalance takes over. The sun-facing side of the planet begins to heat without pause. The surface warms. The air near the ground becomes lighter, rising quickly. That heat doesn't just sit there, it wants to move. And the only place to go is away, from the center of the hot zone outward in all directions. On the night side, the opposite happens. Air cools, it sinks, it grows dense and heavy. And that dense air wants to move too toward the warmth, toward the rising air on the other side of the planet. The result is a massive pressure difference, not a gentle gradient, but an extreme imbalance. One side of the Earth becomes a source of continuous updraft. The other becomes a reservoir of sinking air. The atmosphere, trying to equalize itself, begins to move with force. This isn't like the wind on a stormy day. It's not gusts or squalls. It's continuous, directional, planetary scale wind. And it doesn't start quietly on the edges between the hot and cold sides. What used to be sunrise and sunset zones. The air moves the fastest. Heat rises on one side. Cold air rushes in to replace it. The winds pick up, tens, then hundreds of kilometers. Eventually, they exceed anything we've built for. Cities on the twilight edge become danger zones. Buildings designed for earthquakes or regular storms begin to bend and sway under forces they weren't engineered to survive. Power lines snap. Windows explode inward. Anything loose becomes a projectile. Even trees, roots, and all are pulled from the ground. Sandstorms return to places that haven't seen them in decades. Dust, carried from long, dry riverbeds, sweeps across continents. Salt from evaporated inland seas is lifted into the air and blown into once distant regions, coating rooftops and skin. Farmland turns to powder and vanishes on the wind. Desertification accelerates, not over centuries, but in seasons. Airlines shut down. It's not just unsafe to fly, it's impossible to chart a path through turbulence that changes by the hour. Airports near the edge zones are abandoned. Runways crack, radar systems fail, ground crews relocate. The air, once used as a highway, is now a hostile, unpredictable force. The oceans, still recovering from their own movements, are stirred again. Surface waves don't just rise, they're pushed hard in one direction, creating giant fetch zones that build larger and faster swells. Coastal regions, once thought safe from tsunamis, now face a different kind of flood. Wind-driven surges that batter seawalls and climb farther inland than ever recorded. On the day side, the air rises so quickly that storms become stationary. Convection towers, columns of rising hot air, stretch miles into the atmosphere. Clouds build but don't drift. Instead of moving storms, you get parked ones. A thunderstorm might last, not for hours, but for days, dumping rain in patterns that erode cities and flood plains. Lightning becomes constant. Sky flashes become a normal part of the daylight. On the night side, that same cycle plays out in reverse. High-altitude air, cold and dense, sinks rapidly. The descent creates powerful downdrafts. Whole valleys fill with air that pours down from mountains like invisible avalanches. It doesn't come in bursts. It comes like a faucet turned all the way open, relentless, loud, violent. Where those two sides meet, the zones of eternal sunrise and sunset, the wind becomes something else entirely. A band of unbroken motion, a belt of screaming air that circles the globe, funneling from one hemisphere to the other. It's strongest at the surface, but it reaches high into the sky, slicing through the atmosphere like a saw blade. This is where life becomes most difficult. Infrastructure doesn't last long there. Anything exposed is worn down. Metal fatigues, paint strips off buildings in layers, roads are scoured clean, crops won't grow. Even breathing becomes difficult without protection. Air isn't just fast, it's filled with debris, with particles picked up hundreds of kilometers away. It's not wind anymore, it's a grinding, living thing. In some places, people move underground. Old mines, tunnels, subway systems are retrofitted into shelter zones. Entrances are sealed. Airlocks are built, filters hum constantly. Everything is designed around pressure and flow, about keeping the outside out. Life becomes quieter, not from peace, but from insulation. Technology adapts. Wind turbines are redesigned, not to harvest energy from a gentle breeze, but to survive continuous strain. They turn slower, with thicker blades anchored deep. Energy becomes decentralized. Local wind harvesting, backed by underground battery systems. Solar panels, useless on the night side, are redesigned for concentrated light zones. Energy-sharing networks emerge, balancing the power between too much and not enough. Vehicles are modified too. Power cuts become regular. Heat-related illness rises. Emergency services struggle to meet demand. Governments introduce heat curfews, guidelines that restrict outdoor work during peak radiation hours. Some countries adopt siesta-style schedules, but stretched across weeks. Others move to nocturnal shifts entirely, and still the sun stays there. The idea of time begins to fracture. People no longer measure days by sunrise and sunset. Instead, they mark time by degrees, by the angle of the sun, by the feel of the heat. Some communities invent new systems altogether. Instead of clocks, they use thermal markers. Time is defined by temperature thresholds. Morning ends when it hits 30 degrees. Afternoon begins at 40 degrees. Evening doesn't come until the temperature drops below a certain point. Birthdays, holidays, anniversaries, these become harder to track. Cultural calendars begin to disconnect from the environment. Rituals that once involved candles or sunrise vigils are adapted to indoor, shaded ceremonies. Traditions shift, not because people forget them, but because the setting no longer supports them. Children grow up never knowing what it means for the sky to turn dark on its own. Bedtime becomes arbitrary. The sky tells no stories. There are no constellations, no fireflies, no fireworks lighting up the night sky. Only controlled environments, blackout curtains, artificial dusk. Children draw suns with no horizon. For some, it becomes a symbol of resilience, a reminder that humanity adapts, that we reshape our world to fit what we're given. But for others, it's a quiet grief, a kind of mourning for something most people never thought to miss. In the rare places where the sun is low in the sky, near the edge of the Terminator line, the moving frontier between endless day and endless night, there's still a semblance of rhythm. Not fast, but noticeable. A hint of change. People flock to those regions. They become valuable, contested. A narrow band where twilight lingers for months. where temperature swings are mild enough to survive, and the light still shifts just enough to mark the passage of time. New cities rise there, slow-moving ones, caravan cities that inch across the surface, following the sun's gentle descent. Infrastructure designed to be mobile, buildings on rails, farms that rotate slowly. People live their entire lives within a traveling zone that circles the planet once a year, staying forever on the edge of day or the edge of night, depending on which direction they follow. Some call them horizon chasers, others call them the last keepers of natural time. But most people stay where they are, because even if the day lasts forever, life finds a way to organize itself. Even if the sun never sets, people still sleep, work, argue, love, and grow old. They build structures, write books, send messages. They create rhythm where none is provided. They generate meaning in stillness, because the sun, for all its power, doesn't tell stories. People do. And while one side of the planet lives on a permanent day, the other half faces something colder, darker. Not because the sun is gone, but because the world no longer turns to meet it. The dark doesn't come like it used to. It doesn't slide across the sky as the sun dips below the horizon. It doesn't bring with it the cooling of evening or the soft rhythm of nighttime sounds. It doesn't carry the promise of morning. On this side of the planet, the dark arrives once and then never leaves. The night that never ends doesn't begin with panic. It begins with confusion. At first, people thought it's a storm, maybe volcanic ash, maybe some kind of eclipse, something temporary, something that will lift in a few hours or a day. Power stays on, lights stay bright, schedules stay unchanged. But then the second day comes, and it's still dark, and the third, and then a week, and the sun hasn't returned. It doesn't take long for people to realize that something fundamental has shifted. In those early weeks, there's a kind of stubborn optimism. People install more lights. Stores sell out of lanterns, bulbs, and backup batteries. Solar panels become useless. Generators become precious. There's a rush on fuel. Candles flicker in the windows. Communities come together in a kind of forced calm. They remind themselves that it's only darkness. Nothing's broken. Nothing's on fire. The ground isn't shaking. We've dealt with worse. But then the cold starts to settle in. Without the sun, the surface of the planet begins to lose heat. It doesn't happen instantly, and some areas hold on longer than others. Coastal zones, places with deep rock beds that store warmth, cities built over hot infrastructure, but none of it lasts. Within weeks, nighttime temperatures drop below freezing in most regions. Within months, the average dips further. Lakes freeze, rivers slow. Ground that was once soft becomes brittle. Buildings crack, doors swell in their frames from the frost. Breath turns to vapor inside as well as out. People start to layer up indoors. Multiple sweaters, gloves, scarves, blankets stacked in corners. Shared body heat becomes essential. Old homes that were never designed for this level of cold become inhospitable. Pipes burst, walls sweat ice. Some families move into a single room, seal the doors, and heat only that space. They sleep in shifts, taking turns keeping fires burning. Plants wither in the darkness. Without photosynthesis, they can't grow. They can't be repaired. Gardens die. Indoor plants drop their leaves. Food stored in basements begins to freeze solid. Crops left in the field rot or turn to mulch. The agricultural clock stops ticking. Farmers look at frozen soil and know it won't recover anytime soon. Wildlife goes silent. Birds migrate. At first out of habit, then out of instinct, but there's nowhere to go. Animals that rely on daylight for foraging struggle. Predators can't hunt in the cold. The prey can't find shelter. Insect populations collapse. Food chains fragment. The silence becomes heavier, and the dark doesn't move. People stop talking about days of the week. Weekends don't mean anything. Without sunlight, it's hard to tell when one day ends and the next begins. Digital clocks still tick, watches still beep. But they feel disconnected, like reminders of a system that no longer applies. Time becomes more about routines, the number of hours someone stays awake before they sleep, the cycles of meals and conversations, the rhythm of generators running low and needing fuel. Shift work becomes important. Families set up rotating schedules. Who sleeps when? Who tends the fire? Who checks on neighbors? Social life becomes compressed. People cluster in warm places, churches, schools, libraries. They stop being institutions and start being shelters, places with structure, with lights, with people to talk to. Mental health becomes a quiet crisis. The absence of light affects the brain in ways not everyone expects. Some people feel sluggish. Others feel anxious, even paranoid. Small arguments stretch into days, relationships fray, attention spans shorten, motivation dries up. Without the normal cues of morning and evening, the brain struggles to maintain focus. Memory becomes unreliable. People forget what day it is, what time, what they meant to do yesterday. In wealthier regions, there's more infrastructure to support the transition. Artificial lighting systems mimic daylight cycles. Buildings are retrofitted with heating grids. Psychological support services expand. Virtual reality programs become popular, especially ones that simulate outdoor scenes, beaches, forests, and sunlight. Even artificial shadows help. In less prepared places, it's harder. Fuel shortages begin. Families ration power. Some go days without electricity, relying on candles and body heat. Entire towns are evacuated when power grids fail. Rural homes are abandoned. Cities swell with people fleeing the cold, looking for light. Infrastructure strains, blackouts increase, tempers flare. And then there's the problem of food. On the night side, agriculture is no longer possible outdoors. Everything shifts indoors. Grow lights, hydroponics, nutrient solutions, but energy is expensive, food production slows, imports become difficult. Transportation is slowed by snow, ice, and dark roads. Some regions begin to hoard. Others try to trade with the sunlit side of the planet, but long-distance shipping becomes unreliable. Air routes are unpredictable without jet streams. Shipping lanes freeze over. Governments establish ration programs. Greenhouses are prioritized. Staple crops like potatoes, wheat, and leafy greens are grown under constant LED light. Lab-grown protein becomes more common, not because it's trendy, but because livestock farming in darkness is unsustainable. Chickens won't lay eggs without light. Cows eat more in the cold and produce less. Pigs can't regulate their body heat. It's not just economics, it's biology. Communities that survive do so because they adapt early. Homes are redesigned to trap and reuse heat. Waste heat from computers, kitchens, and machinery is redirected into shared spaces. Cities build geothermal plants, tapping into the Earth's core warmth. No more light plastics. Everything is armored. Sensors help drivers navigate invisible currents. In some regions, roads are replaced by underground transit corridors. Personal transport is replaced by collective shelter-hopping systems. It's not about going far. It's about staying safe between 2 points. People begin to speak a new kind of language around the wind, not just speed, but texture, sound, presence. It howls. It keeps. It presses against walls like a force looking for entry. Children grow up learning not to fear it, but to respect it, to measure its moods, to listen for its warnings. Weather alerts are constant, not about storms, but about shifts, about pressure changes, about when to stay in, when to wait. Cultural practices evolve. Traditional kite festivals, once symbols of joy and freedom, are reimagined as low-altitude art installations, safely anchored and never airborne. Music incorporates the sound of wind, recorded from outside shelters and woven into compositions. Art made from wind-eroded surfaces becomes collectible. The markings are seen as a record of time passing in a still world. Even indoors, people feel its influence. Buildings breathe differently, small leaks become howling voids, insulation is constantly maintained, architecture starts to bend with the wind instead of fighting it. Homes are no longer built upright. They are flattened, low-slung, contoured like sand dunes. Even cities begin to reshape. Clustered layouts, rounded edges, everything aerodynamic. And despite all this, people still go outside. They have to, for repair work, for infrastructure, for exploration. Some out of necessity, others out of principle. The ones who venture out wear suits, pressurized, filtered, weight-balanced. Some of them are scientists, some are farmers, some are messengers. A few are simply drawn to the world as it is now. Loud, volatile, stripped of illusion. They come back with stories of what the land looks like beneath the screaming wind, how trees have grown sideways, how rocks have worn smooth on one side and jagged on the other, how the sky, for all its rage, still opens up into quiet patches, how even in the most violent gusts there's still a rhythm. Not the old one, a new one, less predictable but present. And then they go back inside, the airlocks hiss shut, the filters cycle, and the silence returns. The wind keeps going though. It doesn't stop. Not until the heat and cold find balance again. Not until the planet shifts once more. Not until motion somewhere returns. But the atmosphere isn't the only thing that's changed course. Because with the winds unleashed and the air reshaped, the oceans start to answer back. And that, as we'll see, is a different kind of movement altogether. The oceans are the heaviest moving things on the surface of the Earth. They hold more momentum than any wind, more mass than any landform, and they don't stop easily. They stretch over 70% of the planet. And when something changes on a planetary scale, like the rotation coming to a halt, the oceans don't just sit there, they move. And once they start, they keep going. On a rotating Earth, water is pulled toward the equator, not by gravity alone, but by the centrifugal force created by the planet's spin. It's subtle. You don't feel it, but it's enough to make the sea bulge outward along the midline of the world by over 8 kilometers. That bulge isn't a wave. It's a quiet, massive redistribution. Water pushed gently toward the middle, where it stayed for billions of years. Take away the spin, and that force disappears. Slowly or suddenly, the oceans begin to shift. The bulge begins to flatten, and water starts to run downhill toward the poles. If it happened fast, the results would be catastrophic. Sea levels would drop at the equator and surge at the higher latitudes. Entire coastal regions in the tropics would dry up. Coral reefs would be left exposed. Shipping routes would vanish, replaced by barren seafloors and fractured infrastructure. Meanwhile, places close to the poles, Canada, Northern Europe, Siberia, Antarctica would flood, not from storms or rain, but from the steady rise of a sea that has nowhere else to go. Cities that once sat safely inland would find themselves at the edge of a growing inland sea. Towns in Scotland might become port cities. Parts of Greenland would be underwater. The shores of the Baltic Sea would expand by hundreds of kilometers. New estuaries, new floodplains, new coastlines, all carved by water, no longer held in place by motion. In a slower scenario, these changes would unfold over decades, perhaps centuries. Not sudden, but relentless, like a tide that never goes out. Governments would redraw maps annually. Scientists would model the shifting shorelines. Engineers would abandon old seawalls and begin building entirely new ones, not to protect against waves, but to buy time from the creep of planetary redistribution. The oceans don't move evenly. Water isn't poured from one bucket into another. It finds paths of least resistance. It spills over lands, seeps into valleys, climbs river systems. The Mississippi might reverse in places. The Amazon basin could become a shallow inland sea. Islands, once isolated by thousands of kilometers of ocean, might be joined by land bridges, while others, once safely tucked near the poles, would vanish under rising saltwater. And then there's the temperature. The sun-facing side of the Earth bakes. Without night to cool the surface, evaporation becomes constant. Oceans on that side don't just sit under the sun. They lose water to the air in staggering amounts. Clouds form, but without rotation to move them, they gather in clusters. Some areas flood with rain, others become humid deserts. Moisture overhead, but never falling. Salinity increases, warm water evaporates, leaving salt behind. The balance of life in the sea shifts. Some species disappear, others migrate toward the edges, seeking cooler, deeper waters. Fish populations that once followed regular migratory routes begin to vanish from fisheries. Entire coastal economies are thrown into chaos, not by overfishing, but by an ocean that no longer follows the old rules. On the dark side of the planet, the opposite happens. The oceans begin to freeze. At first, it's just the surface. A crust of ice forms over calm bays and shallow seas, but without sunlight, the cold deepens. The freeze thickens, lakes become ice blocks, harbors become still, and eventually even parts of the ocean begin to lock into place. The process isn't as fast as it is on land. Saltwater freezes more slowly, but given time and darkness, even the great open seas yield. Shipping ceases in those regions. Icebreakers can't keep up, buoys vanish under frost, docks are torn apart by expanding ice, underwater pipelines are stressed and cracked, ports that once bustled with trade become stranded outposts. In some places, people carve tunnels through the ice to access submerged infrastructure. In others, they simply leave. Beneath the ice, the story is more complex. Water continues to move, but slowly. Ocean currents, the great conveyors that circulate heat and nutrients around the globe, begin to fail. They're partly driven by wind, but also by differences in temperature and salinity. When the surface freezes and when evaporation patterns shift, those differences fade. The circulation slows in time. Some currents stall, others reroute. The Atlantic meridional overturning circulation, a key component of Earth's climate system, weakens. Warm water no longer travels north as effectively. Europe, which relies on ocean heat to moderate its winters, begins to experience deeper cold on the night side. Tropical waters stagnate, oxygen levels drop, marine life suffers. The deep ocean becomes less active, less hospitable, less alive. Coastal upwelling zones, regions where cold, nutrient-rich water rises to feed ecosystems, disappear in some places. Fisheries collapse. Species that depended on predictable currents lose their breeding grounds. Jellyfish proliferate, algae blooms spread. The balance shifts from complexity to simplicity, from abundance to survival. Coral reefs, already stressed by warming, die rapidly, not just from heat, but from instability. pH levels change, water chemistry becomes less stable. Bleaching events increase, then become permanent. The reefs crumble, fish that once nested in their structures vanish. Island nations lose their natural breakwaters. Waves strike with more force. Erosion accelerates. On the twilight edge, the border between the perpetual day and the endless night, the ocean's surface is in constant motion. Here the winds scream and the water rises to meet them. Waves stack on waves, colliding from different directions, unrestrained by global circulation. Rogue waves become common, not rare anomalies, but regular features. Walls of water rising from an already volatile sea. In these zones, seafaring becomes nearly impossible. Buoys are shredded, sonar becomes unreliable. Autonomous drones are sent instead, equipped to handle weeks of turbulence. They gather data, scan the seafloor, and transmit warnings. Some cities are rebuilt as amphibious habitats, floating neighborhoods, stilt homes anchored in place, modular pontoons that rise and fall with the sea. Others give up on the coast entirely, pulling back to higher ground, leaving behind drowned infrastructure and salt-cured skeletons of old industry. Salt intrusion becomes a problem. Far inland, aquifers near the coast are poisoned by the advancing sea. Wells turn brackish. Crops wither from the roots up. Fresh water becomes a geopolitical issue, not just a resource, but a currency. Countries trade in river access. Water-sharing agreements become global priorities. The psychological shift is hard to measure. People still gather at the water's edge. They still watch waves. They still listen to the tide, though it behaves differently now. Beaches still exist, but they change shape more often. Some people visit them to remember what was. Others avoid them entirely. Too many memories tied to what the ocean used to mean. Children grow up learning different ocean stories, not about sailors and sea monsters, but about currents that stopped moving, fish that disappeared, coastlines that changed shape overnight. They still draw waves, they still imagine islands, but the stories have a colder edge. Some find new wonder in it, in the deep, in what still thrives beneath the ice, in bioluminescent creatures never seen before, in vents that continue to steam at the bottom of a frozen sea, in the idea that life, even here, finds a way forward. Science shifts its focus. More funding goes into deep-sea exploration, cryoecology, polar marine biology. Submarines have become more common than ships. Deep-sea stations replace surface vessels. New life forms are discovered. Extremophiles that seem to ignore the chaos above. Bacteria that metabolize heat in silence. Creatures that drift, unchanged through currents that barely move. The oceans haven't died, but they've changed. Their surfaces louder, their depths quieter, their borders redrawn. And as water finds its new balance, so too does the land, because the redistribution of oceans shifts the weight of the planet itself, and what lies beneath starts to answer back. Gravity is one of those things you don't think about until it stops doing what you expect. We live with it constantly. We feel its pull with every step, every fall, every item dropped from a counter. It shapes our bones. It defines the limits of our bodies. It holds the oceans in place, keeps the atmosphere wrapped around the planet, keeps your tea from drifting off into space. But even gravity, so steady, so quiet, is not immune to change. When the Earth was spinning, centrifugal force did a small but important job. It pushed everything outward just a little. At the equator, that force worked against gravity ever so slightly, reducing its strength. You wouldn't notice it unless you measured carefully, but technically you weighed a little less there than you would at the poles. Not because gravity itself changed, but because the outward motion of the spinning Earth gently counteracted it. When the Earth stops spinning, that counterforce disappears. Gravity, no longer having to compete with the centrifugal push, tightens its grip. Not dramatically, but enough to notice. The difference isn't crushing, it's subtle, an increase of about 0.3%. A person who weighs 70 kilos would now weigh about 70.2. Not enough to knock you over, but just enough to feel it in your joints after a long day. Stairs might seem steeper. Lifting boxes is a little more tiring. Sports records would quietly stop being broken. Running would feel heavier, jumping shorter. It's not a new gravity, it's just gravity returned to full strength, but the real changes happen on a larger scale. The shape of the Earth isn't perfectly round. It's an oblate spheroid, wider at the equator than from pole to pole. That bulge exists because of the spin. Centrifugal force has pushed mass outward along the middle for billions of years. Take that spin away, and the bulge starts to relax, not quickly but slowly and steadily. Over thousands of years, the planet begins to settle into a more spherical shape. The equator pulls inward. The poles relax outward. It's not something you'd see from your window, but satellites would track it. Geologists would model it. The crust, once flexed by the pressure of spin, begins to adjust. And with that adjustment comes movement. Tectonic plates shift, not from deep mantle convection as they usually do, but from surface redistribution. The ocean, now pressing toward the poles, adds weight in places that were once light. Land, now free of the ocean's weight at the equator, begins to rise, not in leaps, but in slow, creeping millimeters. Whole regions tilt, coastlines adjust, mountains gain new stress, valleys deepen or compress. Ancient faults that were dormant might wake under new pressure. Earthquakes become more common, not because the planet is angry, but because it's trying to settle into a new balance. Old faults shift, new ones form, seismic zones expand, places once thought stable experience tremors. Construction codes are rewritten, high-rises are re-evaluated, dams are tested, tunnels are reinforced. Volcanic activity changes too. Pressure deep within the crust finds new escape paths as the shell of the planet adjusts. Magma chambers, once content to sit dormant, now swell with new stress. Eruptions occur in regions that haven't seen lava in recorded history. Island chains grow. Ash clouds appear over unfamiliar skylines. All of this is tied to weight, where it shifts, where it gathers, where it recedes. And weight doesn't just affect rock, it affects water. Glaciers, those massive frozen rivers, are particularly sensitive to pressure. On the dark side of the planet, where cold persists, new glaciers form, not just at the poles, but anywhere the climate supports long-term freeze. These new glaciers are heavy. Their weight presses down into the crust, displacing land. Nearby valleys flood. River paths change, watersheds reroute. On the bright side of the planet, glaciers retreat faster than ever. Ice that took centuries to form melts away in decades, and where the ice disappears, the land rebounds, slowly lifting without the burden. This phenomenon, known as isostatic rebound, isn't new, but now it's global and faster. The crust flexes almost imperceptibly, but with consequences that add up. These shifts over time change elevation patterns across the world. Mountain ranges become more jagged in some places, more rounded in others. Erosion accelerates in exposed zones. River deltas, newly unsupported, begin to sink. Lakes form where none existed before. Plateaus gain new lakes. Deserts grow shallower basins. Mapping the Earth becomes a moving target. Cartographers adjust elevation data yearly. GPS systems update constantly. Engineers consider land elevation to be temporary, designing bridges and roads with modular footings that can be raised or shifted as needed. Buildings include leveling systems. Neighborhoods on the move are no longer science fiction. They're just good planning. Even the core of the Earth responds. The molten outer core, the source of the planet's magnetic field, is influenced very slightly by the distribution of mass above it. Changes in that distribution ripple downward. The balance of the core shifts. The movement of molten metal inside changes. And with it, the magnetic field begins to fluctuate. The field, already weakened by the cessation of spin, becomes less stable. Magnetic north begins to drift more rapidly. Some regions experience compass reversal. Navigation systems, especially those relying on magnetism, must be recalibrated constantly. Satellites compensate, aircraft adjust. Some worry about the long-term effect on radiation shielding. The magnetic field protects the planet from solar wind, cosmic rays, and charged particles. As it weakens, more radiation reaches the surface, especially near the equator, where protection was once strongest. Not deadly at first, but enough to affect electronics, to raise long-term cancer risks, to change what safe exposure means. In response, material science adapts. Buildings are constructed with radiation shielding layers. Vehicles include protective coatings. Wearable tech monitors radiation in real time. Space agencies update launch protocols. Solar events, once tracked primarily for astronauts and satellites, are now followed by city planners and health officials. And still, the Earth keeps adjusting. Gravity doesn't stop pulling. The crust doesn't stop shifting. The planet doesn't stop trying to make sense of its new shape. Life goes on, but differently. People start to think of location in new ways, not just by country or climate, but by gravitational profile. Some regions are slightly heavier now, others lighter. Athletes notice it. Health data reflects it. Pregnancy rates change slightly in certain regions. Even cooking changes. Boiling points shift, baking formulas are tweaked, brewing coffee becomes an exercise in calibration. Tourism changes. People visit places not for beaches or cities, but for gravitational oddities, places where gravity pulls just a little stronger. Museums include exhibits that let visitors feel the difference, tiny but real. Amusement parks incorporate gravity rooms. Artists use the idea metaphorically. Songs are written about the weight of stillness. Books explore characters who move between heavier and lighter regions and how it changes them. And underneath all this, the Earth continues to stretch, creak, adjust. Because a planet, like anything under pressure, finds a way to rest when motion is taken away. It doesn't snap, it doesn't collapse, but it does shift. And those shifts ripple upward into everything we do, into where we live, how we build, how we measure, how we understand the ground beneath us. And while gravity works quietly, another force has been making its own slow adjustments. Not to weight, but to orientation. Because if the planet has stopped spinning, the places we think of as home are no longer where they used to be. Not just in climate or time, but in position. The equator used to be in a hurry, not that you could tell by looking. The trees didn't lean into the motion, the soil didn't blur, but if you were standing anywhere along that wide belt of Earth, you were moving faster than anyone else on the planet, more than 1,600 kilometers per hour. Every second, without trying, you were spinning through space faster than the speed of sound. It didn't feel like motion, but it was there, held in the tilt of the sun, the direction of the winds, the gentle outward push of centrifugal force. And then it stopped. Not in an instant, but over time, like slowing a massive wheel. And when it did, everything along the equator paused, not just motion, but identity. Because the equator isn't a line drawn on a map. It's a condition, a product of motion, momentum, bulge, heat. It's where the sun passes overhead at least twice a year, where the day and night are almost always the same length, where the climate hums with balance, where clouds build and rain falls and then clears again. Without spin, that condition changes. First, the sun no longer crosses overhead. The sky becomes static. If the equator falls within the perpetual day side, it sees sunlight without motion, not overhead, but frozen at an angle. If it lies within the dark half, then the equator becomes a line of shadow with no warmth, no cycles, just stillness. And that balance, once so defining, begins to unravel. The heat used to rise at the equator, fueling air circulation. It was the engine that drove the Hadley cells, warm air lifting at the center of the planet, moving toward the poles, cooling and sinking. This pattern created the trade winds, the tropical rains, the monsoon systems. It shaped jungles, deserts, and coastlines. Now, with no rotation and the sun fixed in place, those cells collapse. The air still moves, but not in neat global loops. It flows chaotically, driven by localized heating and cooling, not by spin. On the side of the planet where the equator faces the sun, the heat doesn't rise and move. It just accumulates. The land bakes, water evaporates, clouds form, but with nowhere to go. Rain falls in bursts, or not at all. Humidity climbs until the air can't hold more moisture. Then it dumps it all at once. Instead of a daily rhythm of storm and sun, the equator becomes a place of extremes. Weeks of oppressive heat, days of torrential flooding, soil can't recover. Plants either adapt to soak or starve. Traditional agriculture fails. Humidity ruins storage. Disease spreads faster. Mold becomes a daily threat. Infrastructure is designed not for seasons, but for saturation. On the opposite side of the world, where the equator sits in darkness, the change is colder, but just as severe. It wasn't supposed to be cold at the equator. That was part of the definition. Now, without sunlight, it freezes. The atmosphere thins. Tropical forests built for endless growth begin to collapse. Trees die standing, vines dry into wire, insects disappear, birds migrate into the night and never return. Rivers slow, then stop. The Amazon becomes a long basin of cold mud, then frost, then silence. The equatorial ocean, once warm and lively, begins to cool. The coral dies, the fish leave. Coastal communities, built around fishing, collapse, not from overuse, but from abandonment. The identity of the equator as warm, lush, fertile, gone. And with the end of rotation, something else becomes possible. Land doesn't just sit under its own weight anymore. The planet begins to settle into a new shape. The equator, no longer pushed outward by motion, starts to relax. Over geological time, it flattens. This process is invisible at first, but over decades it becomes measurable. The sea recedes from equatorial coasts, pulled back toward the poles. Old harbors are left stranded. Coral reefs are exposed to the air and bleach dry. New peninsulas form where once there was water. Islands become part of the mainland. Old sea maps are useless. The shape of the continent stretches and contracts like slow breathing. And the land itself lifts, not dramatically, maybe a few millimeters per year, but enough that elevation changes. Lakes become more shallow. Land jungles rise into dry plateaus. Animals migrate. Insects vanish. Soil dries and cracks. Plants evolve or perish. Whole biomes move not by migration, but by displacement. Cities built on the assumption of tropical stability must adapt. Their architecture, their food supply, their water storage, all must be redesigned for either a drying, rising land or a freezing, dark one. Cultural identities rooted in equatorial life shift as well. Many equatorial regions have deep traditions tied to the sun's motion. Solstices, zenith crossings, seasonal rains. Without those, rituals are decoupled from the environment. Some are preserved, others are adapted. Festivals become more symbolic. Some are moved indoors. Others are marked by artificial light cycles. Language changes too. Words that once described the heat, the rains, the short twilights begin to fade from daily use. New vocabulary emerges around the constant sun, the unbroken dark, the shifts in soil. Farmers speak not of planting seasons, but of survival windows. Urban planners talk in terms of flood curves and evaporation rates. Equator becomes a technical term again, useful for maps, but less so for life. Some regions embrace the change. They develop new models of living. Equatorial cities build climate domes, massive structures with internal weather systems. Not just malls or greenhouses, but entire neighborhoods with programmed rain, wind, sun. Schools teach local weather as a setting, not a pattern. Tomorrow's sky will be 30% clouded, a child says. We're due for a simulated drizzle. Others struggle. Poverty deepens where adaptation is slow. Aid organizations shift their focus, not to disaster relief, but to long-term transformation. Architects and anthropologists work together, designing spaces that maintain cultural roots while facing a new physical reality. Technology becomes the bridge. But not everyone stays. Migration from the equator increases. People move toward the twilight bands. Areas with slightly more balance, less heat, less cold, less wind. Population corridors shift. Equatorial nations lose residents. Governments rethink borders. Remote sensing data becomes essential, not for security, but for understanding who's still there. Some stay by choice, by necessity, by stubbornness. They build shade systems, underground water collectors, and windbreaks. They don't expect the equator to return to what it was, but they learn to live with what it is. They teach children how to read a sky that doesn't move, how to grow food in unpredictable rain, how to live in a region that takes everything once regular and turns it inside out. And over time, even here, people begin to create rhythm again, new calendars, new festivals, new ways of marking the year. Because while the equator might have taken a breath, long, deep, still, it didn't disappear. It just changed, and so did everything around it. But that change isn't limited to place, it extends to identity. Because if your geography is shifted, and your climate and your traditions, then so is your position in the world, not just physically. No one feels their home move. The buildings stay in place, the streets still curve the same way, the mountains in the distance don't shift. And yet, in a world without spin, you're no longer where you think you are. Not just in climate, not just in culture, in literal position. You didn't just live in a city or a country. You lived on a turning surface, swept continuously eastward. That motion gave context to where you were. It influenced weather, light, air, and gravity. It gave everything a rhythm. But when the planet stops, those rhythms break. And over time, the lines we use to define places begin to drift. Polar regions sink under the weight of new seas. Equatorial regions, relieved of that weight, rise. Coastal cities at mid-latitudes begin to lift from the water's edge. But it's not just elevation that shifts. It's latitude. The equator, as a geographical marker, used to be fixed by rotation, a product of the spin defined by the bulge at the waist of the planet. Now that the bulge is shrinking, the shape of the Earth is smoothing out. The crust is moving in response. The surface is subtly rearranging itself from an oblate spheroid to something closer to a sphere. As that happens, your latitude changes, even if your feet never leave the ground. Someone who once lived at 5 degrees north might now live at 3 degrees. Not overnight, but over years. Not measured in steps, but in models, in satellites, in the long, quiet observations of Earth. Scientists tracking the shifting surface of a planet, realigning under new forces. Cartographers stop updating maps based on political change. They update them based on the motionless redistribution of mass. Countries don't move, but their outlines shift. Rivers flood into new basins, deserts expand, mountain ranges settle, old landmarks disappear beneath rising seas or re-emerge as dried-out basins. Entire cities gain new climates, not just because of temperature, but because of their shifting position relative to the sun's frozen point. A city that once sat squarely in the tropics now sits in a high-pressure belt of dry air. Another, once dry and cool, becomes part of the perpetual sunlit zone. Weather patterns, once familiar, are gone, and people feel it. At first, it's a background detail, something mentioned on the news, a note in school curriculums, small print on new maps. Then, it becomes more obvious. Postal systems begin adding climate zone tags. Emergency alert systems are updated with new geographic risk profiles. A town, once classified as inland, becomes coastal, seasonal. A village, once in a temperate region, becomes arid, elevated. Migration increases. People relocate not just to avoid heat or cold, but because their homes no longer match the environment they were built for. Houses designed for heavy rain now sit under dry skies. Farms built in highlands are now on flat, dry plains. Roads buckle under new patterns of erosion. Power grids stretch in new directions. Real estate changes, not based on neighborhood or school district, but on solar exposure, on proximity to habitable climate zones, on distance from flooding polar coasts, on elevation trends. People no longer ask, "Is this area growing?" They ask, "Is this area stable?" Some regions capitalize on the shift. They brand themselves as twilight corridor safe zones. Moderate temperatures, light seasonal wind, manageable elevation drift. People move in, businesses follow. Urban planners study old climate models and layer them with new elevation data to forecast future centers of gravity, economic, social, and literal. And while the change is slow, it affects something deeper. our sense of identity. People tie who they are to where they're from, but what happens when where you're from no longer exists? When does the name on your birth certificate refer to a town now underwater? When your family's farmland, passed down through generations, lies beneath new glacial runoff? When the mountain you grew up next to has cracked and sunk under a shifting fault line? Some adapt. They create new traditions, new place names. They carry forward memory in other ways. But others feel the loss in a more personal way. Not dramatic, not loud, but like something always slightly out of place. Geolocation services try to adapt. Apps that once told you the best route through traffic now alert you to shifts in elevation. Delivery systems reroute based on newly formed hills or valleys. Augmented reality tools overlay old maps onto current topography, letting people walk streets that technically no longer exist. Education changes. Geography lessons no longer begin with latitude and longitude. They begin with mobility, not the movement of people, but the slow motion of the land itself. Children learn about post-equatorial Earth. They learn to think in flexible borders, in climates as evolving zones. They're taught that place is no longer a fixed point, but a dynamic condition. And there are debates, cultural, political, even philosophical. If your village moves north by 3 degrees over 2 generations, is it still the same place? If your country's borders were drawn based on a river that now flows in reverse, should those borders change? If your capital city no longer sits near the center of the nation, but at its new southern edge, should the capital move? Some argue for redefining everything. A new set of world lines, a new prime meridian, a new 0 point for human mapping. Others resist. They hold on to old charts, old models, old names, not because they're more accurate, but because they feel more real, and still the ground keeps shifting. Not in sudden earthquakes or eruptions, but in the slow release of a planet unwinding, of tension leaving the crust, of weight moving from one region to another. And every time it does, your place on the planet inches into a new position, imperceptible on its own, undeniable over time. And beneath that shift is something even stranger. Because with all these adjustments, land rising, oceans draining, maps redrawing, the planet's weather no longer follows any familiar script. And what comes next isn't just a change in scenery. It's a rewriting of the rules that once held the seasons together. The first thing people notice is that the weather stops arriving on schedule. There's no cold front sweeping through on a Tuesday, no reliable build-up to spring storms, no gradual warming through April. The idea of season begins to lose shape. Not because temperatures don't change, they do, but because the patterns that once linked those changes to time, place, and motion have disappeared. For most of human history, weather was shaped by movement, air currents bent by the Earth's spin, heat distributed through circulation cells, clouds pushed across continents by jet streams, storms born in one ocean and driven toward another. But without rotation, the great conveyor belts of the atmosphere grind to a halt. The winds still exist, but now they're not travelers. They're residents. The sun-facing side of the planet doesn't rotate out of the light. It bakes endlessly. The sky is not always blue. It's often white or silver or hazy gold, burned pale by the persistence of sunlight. Air rises constantly from the ground, hot and heavy with evaporated moisture. Clouds form quickly and then stall. They don't drift. They gather, expand, drop rain in sheets over the same region again and again, or they hold it in for weeks, ballooning into towering structures that finally collapse into violent, slow-moving storms. Some areas experience perpetual deluge, rivers overflow, hills turn to mud, foundations rot. Other places just kilometers away stay dry for months. Not deserts in the traditional sense, but places where the rain clouds hang elsewhere indefinitely. People begin to think of weather less like a system and more like a neighbor, stubborn, present, and unmoving. On the night side, everything is different. The cold deepens with each passing month. Snow falls in places that have never seen winter before. Then the snow stops falling because the air is too dry. Water freezes into the ground and stays there, not permafrost, something colder, something still. Weather used to be the planet's way of exhaling. Now, with no rotation, it's a breath held indefinitely. Motionless air systems linger over regions for so long that local climates begin to fossilize, not in stone, but in habit, in expectation. People build around what the weather has become, not what it might become. And then, sometimes without warning, it shifts. Not because of a jet stream or planetary tilt, but because of sudden pressure differences, uneven heating, or terrain forcing air upward until it spills over like an overflowing pot. These are not weather systems, they're ruptures. A sudden windstorm might erupt after weeks of stillness. A tornado, once a traveler down a predictable corridor, now forms in place, twisting on its axis with nowhere to go. Hail falls for hours over one field and never touches the next. Fog settles over cities for days, thick enough to stop all movement, and then lifts in a matter of minutes. Meteorologists, once comfortable forecasting days or weeks ahead, now operate on hours, even minutes. Long-range predictions vanish. Satellite models update in real time, but confidence intervals shrink. Patchy rainfall expected between now and next Tuesday becomes a common phrase, not for lack of skill, but for lack of pattern. On the edges of light and dark, the twilight belt, things are even less stable. This is where weather tries to balance two worlds. Warm air meets cold, moist air meets dry. Pressure systems push into each other and hold. Storms form along these boundaries and don't move. Instead of sweeping through a region, they hover, sometimes for weeks, dropping snow and rain and sleet in patterns that make no sense when viewed on traditional maps. Weather stations in these zones run around the clock. Drones fly constant loops, measuring wind shear, cloud structure, moisture content. People no longer check forecasts. They check live feeds, not to see what's coming, but to understand what's already happening 10 kilometers away. Weather becomes hyperlocal. People carry personal sensors. Homes come equipped with built-in forecasting systems. A typical alert might say, barometric drop detected. Move indoors in 30 minutes. Clothing adapts, not for fashion function, but for reactivity. Jackets that shift insulation levels, boots with heated soles, face coverings that adjust for wind direction. People learn to read the sky with more precision than ever before. Not to understand the season, but to know if it's safe to go outside right now. And then there are the heat zones on the permanent day side, where the sun hangs low and unblinking. Temperatures reach new thresholds. Deserts form in places that once held forests. Sandstorms become routine. People dig down instead of building up. Homes are cooled with earth pipes, water circulation, underground chambers. Streets are shaded with thick fabric stretched across buildings. Open-air spaces are abandoned. Activity happens at night, not night by sun, but night by shadow, by choice, by heat schedule. In these places, rainfall becomes rare but catastrophic. Weeks of dry heat followed by a single hour of flash flooding. Soil can't absorb it. Infrastructure collapses under the sudden weight of water. New drainage systems are designed to move millions of liters in minutes. Some cities invest in vertical catchment towers, massive structures built to collect and store rain before it hits the ground, like umbrellas, but for entire neighborhoods. And then, of course, there's the psychological effect. Weather used to be the background. Now it's something everyone monitors. It becomes part of conversation, not out of politeness, but out of necessity. How's the pressure today? Becomes a question as important as how are you? Headaches, insomnia, and anxiety flare with sudden shifts. People take mood stabilizers, not just for chemistry, but for weather regulation. Art changes. Novels set in the past describe skies that moved, seasons that returned, the quiet relief of predictable rain. Children draw suns that never set, clouds that don't move. Music slows. It mimics the weight of stalled air, the long rhythm of a still sky, and yet people find new kinds of resilience. They plant crops indoors under artificial weather cycles. They invent new ways to capture dew, filter air, and store heat. They relearn old skills. How to read wind by sound, how to tell the temperature by breath. Elders pass on knowledge, not just from science, but from adaptation. From years spent watching a changed sky settle into its new rules. Some try to reclaim seasons. They build digital calendars synced to artificial cycles, light festivals that simulate solstices, engineered rains released at set intervals. People gather to watch artificial storms, controlled, safe, scheduled, not to replace the weather, but to remember what rhythm felt like. Because weather, at its core, was never just about temperature or wind. It was about knowing what came next, about trusting that summer would follow spring, that clouds would pass, that morning frost would melt. It was about rhythm. And now, with rhythm gone, people search for it in other places. In routines, in stories, in the quiet ticking of a watch whose hands no longer match the world outside. And while the weather above changes beyond recognition, something deeper begins to echo that uncertainty. Because the bodies that depend on cycles, humans, animals, plants, have to adapt or be left behind. For most of history, tides have been quiet storytellers. They rose and fell with regularity, pulled by the moon, nudged by the sun, shaped by geography. They whispered the passage of time in ways clocks could never quite match. The sea came in, the sea went out. It marked fishing hours, moon phases, even moods. People built their lives around that rhythm. Boats launched on the high, nets set out on the low. Cities timed their sewage systems to follow the tide. Temples were built to honor it. But with the earth no longer spinning, the rhythm begins to unravel. It starts simply a delay, a hesitation. The ocean pauses at the shore, unsure whether to advance or retreat. Tides, at their core, are a relationship between motion and gravity. The moon pulls at the water, creating bulges on opposite sides of the planet. As the Earth spins, those bulges move, sweeping across the surface, making it seem like the ocean breathes in and out. But when the spin stops, so does that illusion. The water still bulges, but it no longer sweeps. It no longer dances around the planet. It lingers in place, locked in gravitational tension, pulled by the moon, but no longer guided by motion. Coastal areas that once saw 2 tides a day, high and low, now see 1, if any, and it barely moves. On the side of the planet directly facing the moon, the tide remains high, held there by the pull. It doesn't crash or swell. It just sits, persistently elevated, a permanent high tide that slowly reshapes the shoreline. The sand erodes, not from movement, but from pressure. Salt water creeps higher up beaches, not because it's surging, but because it has nowhere else to go. On the opposite side, the point farthest from the moon, a second bulge remains, created not by pull, but by inertia, a leftover from when the oceans once moved in balance. This too becomes a fixed feature. Another stretch of high tide locked in place, unchanging. Between these 2 zones, the sea level rests lower, not as a tide, but as a plateau. No rise, no fall, just a stillness that over time feels unnatural. Ports that relied on the cycle find themselves stranded. Docks built to float now sag uselessly beside their moorings. Ferries run aground, oyster beds dry up, aquaculture farms lose their flow. Coastal ecosystems, adapted to the breathing rhythm of the sea, begin to falter. Mangroves, which depend on the pulse of salt and fresh water, begin to die. Tide pools, once renewed twice a day, stagnate. Species that relied on the changing depth, crabs, clams, sea stars, disappear. They don't go extinct all at once. They just don't return after the last cycle ends. Some coasts adapt. Artificial pumping systems mimic tidal flows in certain bays. Controlled flooding maintains wetlands. Scientists experiment with synchronized sea gates, opening and closing in patterns that simulate the old dance. It's not perfect, but it's something. Farther offshore, the open ocean behaves differently. There, the water is less about tide and more about gravity redistribution. With the equatorial bulge collapsing, some ocean basins deepen, others shift. Underwater ridges rise or fall. Currents change direction, not because of wind or temperature, but because the landscape beneath them is moving. The moon still orbits, of course. Its pull is still there, but it loses some of its voice. In a spinning world, the combination of lunar gravity and Earth's motion created dynamic friction. That friction transferred angular momentum from the Earth to the moon, slowly pushing it farther away, a few centimeters per year. Barely perceptible, but measurable. Now with no spin, that friction ends. The moon stops drifting, its distance stabilizes. Its orbit begins to tighten very slowly, not dangerously, but definitely. Lunar eclipses become less frequent. The length of a month adjusts fractionally, and the night sky gains a new constant. The moon appears in the same position over the same part of the Earth, night after night. On the day side, it becomes a pale presence against the endless sun. On the dark side, it becomes a permanent companion, casting long shadows across ice-covered seas. Culturally, the moon begins to change meaning. Without tides to follow it, the moon is no longer a timekeeper. Calendars, long tied to its phases, drift into abstraction. Moon festivals continue, but more as tradition than astronomy. Children learn about lunar cycles in school the way they learn about spinning tops, a concept from another time. Poets still write about it. Lovers still point it out. But now, it's the stillness that captures the imagination, not the change. The moon becomes a symbol of constancy in a world where everything else has shifted. For animals, the change in tides is more than symbolic. Marine species that spawn based on lunar cycles become disoriented. Grunion, who once flung themselves onto beaches in perfect timing with the highest tide, now misjudge their moment. Turtles, accustomed to crawling ashore during low tide, find the water never recedes. Whales that used to navigate by shifting sea depths must adapt or lose their paths. Some do. They follow chemical cues instead, or temperature gradients, or magnetism. But many do not. For humans, the change isn't just biological, it's economical. Tidal energy systems, once a growing part of the renewable energy portfolio, fall silent. Wave farms are re-engineered or abandoned. Desalination plants that relied on tidal intake must be redesigned. Insurance companies rewrite flood models. Coastal construction shifts to assume a permanent high tide in some regions, a permanent low in others. Cartographers redraw shoreline maps for the third time in a decade. The language of tides becomes ceremonial. Surfers, once obsessed with tide charts, shift focus to wind and swell. Harbor masters rely on historical averages, not predictions. The tide tables are printed less and less, and yet in some places something strange happens. Subtle movements return, not full tides, not the rhythmic dance of old. Oceanographers argue over their cause. Some believe they're the Earth's way of testing balance again. Others say they're nothing new, just amplified versions of old background shifts that were once masked by stronger rhythms. Either way, they're watched, measured, recorded. Because in a world where tides no longer follow the rules, any sign of motion matters, and perhaps more than that, any sign of return. But return isn't the same as recovery. Because even with all these changes, oceans stalled, tides quieted, coasts redrawn, one force still holds power over everything that breathes. And that force is time. Not the kind you measure with clocks, the kind your body keeps whether you like it or not. The Earth doesn't look like a magnet. There are no poles with giant red and blue markings, no iron filings dancing over continents. But deep inside, below the crust and the mantle, beneath everything solid and everything still, there's motion, or there was. The magnetic field that shields our planet isn't a surface phenomenon. It doesn't come from the atmosphere or the crust. It comes from the core, a swirling, churning sea of molten iron and nickel rotating within the planet's heart. This liquid metal moves in patterns, spirals, loops, convection currents, driven by heat and rotation. And those movements create a magnetic field strong enough to deflect solar radiation, shield satellites, guide birds, and keep your compass needle pointing north. It's called the geodynamo. And without motion, it begins to shut down, not instantly. The molten core still has heat. The planet's internal engine doesn't stall in a day. But without the rotation of the outer shell, the patterns inside start to change. They slow. They stretch, the dynamo weakens. As it does, the magnetic field begins to fade. You don't feel it, nothing shakes, no alarms sound. But over months and years, the data begins to shift. Magnetometers record declining field strength. Satellites register more radiation exposure. Auroras, once confined to the poles, begin drifting toward lower latitudes. The sky in regions that never knew them now glows at night in green and red and violet. Beautiful, but not entirely benign. Because what the field was doing wasn't just decoration, it was a shield. The sun doesn't just send light and warmth, it sends charged particles, streams of plasma that race through space at immense speeds, solar wind, coronal mass ejections, radiation storms. In a normal world, the magnetic field deflects most of that, wraps around the planet in a protective bubble, the magnetosphere. Without it, more of those particles reach the atmosphere, more of them reach the ground. At first, the changes are minor, slightly higher radiation levels at high altitudes. Airline crews and frequent flyers start to see higher cumulative doses. Recommendations change. New shielding is installed in planes. Routes are adjusted to avoid flare zones. Then, satellites begin to fail more frequently, not because of collisions or decay, but because their electronics are fried by solar particles. Shielding is added. Redundancy is built in. Some constellations are taken offline. Others are rebuilt with radiation in mind. Satellite internet slows. Communication blackouts during solar storms become normal. Eventually, ground-level radiation starts to rise, especially near the equator, where the magnetic field used to be strongest. UV indexes climb. Skin cancer rates increase. Outdoor labor becomes regulated by exposure limits. Schools build UV-safe structures over playgrounds. Public health announcements include daily radiation forecasts alongside air quality and pollen counts. Technology adapts. Consumer electronics are redesigned with hardening against electromagnetic interference. Power grids install new surge protection. Backup systems run constantly. Transformers are built to absorb or deflect geomagnetic surges. Still, blackouts happen, sometimes local, sometimes not. Insurance companies rewrite policies to include space weather clauses. Solar observatories are funded heavily. Global alerts go out ahead of solar events, not for astronomers, but for everyone. People know the signs. When a major flare is detected, you unplug your devices. You avoid flights. You stay indoors. You wait. Some communities go underground for longer storms. People who once scoffed at solar weather become solar aware, not out of fear, but out of pattern. Another thing to monitor. Another variable in a world where certainty is slowly dissolving. And it's not just technology that feels it, nature notices too. Many migratory animals rely on the magnetic field to navigate. Birds, whales, turtles, all wired to follow invisible lines across the planet. When those lines blur, some lose their way. Nesting grounds go unused. Migrations end in the wrong hemisphere. Scientists try to intervene, using artificial beacons, radio signals, even scent cues to guide them back. Some adapt. Others vanish quietly. Human navigation adjusts. GPS systems rely less on magnetic reference, more on signal triangulation. Compasses become unreliable. Explorers use sun position, satellite guidance, old methods. Adventure gear includes legacy navigation kits. Not for nostalgia, but because batteries can fail in the wrong storm, and still the core keeps shifting. Some theories suggest the magnetic field might not vanish completely. It might fragment, become multipolar, not north and south, but scattered patches of different polarity. The compass doesn't spin in circles. It twitches, it lurches. Maps are reissued every few years. Magnetic anomalies become known features, places where the needle simply refuses to decide. There are periods in Earth's history when the field reversed entirely. Magnetic north became south and vice versa. These reversals took thousands of years. Life survived them. There's no record of a mass extinction tied directly to a flip, but there was always rotation then, always motion to feed the field, even when it stuttered. Now the rules are different. Without planetary spin, there's no stable reference point. The field may recover, it may not. If it does, it will be weaker, more complex, less protective. And that raises the deeper question: what happens to a planet without a shield? Not just to its surface, but to its atmosphere. Because the sun doesn't just heat, it strips. Solar wind, unimpeded, begins to erode the upper layers of air. Slowly, molecule by molecule, hydrogen, oxygen escape into space. Not fast enough to suffocate us overnight, but over centuries, perhaps millennia, enough to matter. Some scientists argue we'll adapt before then. Others suggest early signs are already measurable. Tiny drops in atmospheric density, higher levels of cosmic radiation at ground level. They say it's subtle but measurable, and for the first time in human history, the planet starts to feel slightly exposed. There's no breach, no collapse, just the quiet realization that something invisible, something that's always been there, is fading. And that's what life does when it's not sheltered. It adjusts. But time isn't waiting, because when the rhythms of the sky and sea go silent and the air itself begins to thin, something inside the human mind starts looking for structure again. And when the sun no longer moves and the tides no longer shift, what we look to next is not the stars, but the ticking inside us. Time never needed a clock. Long before hours and minutes, before watches and alarms, time was something felt, something seen in the sky, in the rising and setting of the sun, in the movement of shadows, in the cycles of animals and plants and seasons. For as long as we've existed, the Earth's rotation gave time its rhythm. A constant spin, a 24-hour day, a predictable arc of light and dark. This rotation is what gives us sleep, work, prayer, growth, harvest, rest. It gave us morning, it gave us tomorrow. But now the spin is gone. And with it, time, at least the kind we know, begins to unravel. It doesn't disappear. Clocks still tick. Atomic time remains accurate. Our systems are built on that precision, and they keep it well. But time without rhythm is like music without beat, technically there but hollow. On the sunlit side of the planet, days no longer end. There is no dusk, no signal to wind down, no darkness to cue melatonin, to soothe the eyes, to quiet the world. The body, built to follow light, doesn't know when to stop. People try to enforce schedules. Shutters close, lights dim. Routines are kept. Apps simulate sunrises. Homes are lit to mimic evening. But even with that effort, the body knows. It senses the constant light. Sleep becomes harder. Dreams fragment. Circadian rhythms begin to stretch or collapse entirely. Insomnia becomes common, fatigue chronic. The mind begins to measure time by task instead of sunlight. Work time, rest time, meal time, none of it tied to anything outside. People begin to live on artificial cycles, 20-hour schedules, 26-hour cycles, polyphasic sleep patterns. Some follow isochronal rhythms, a perfectly balanced block of hours repeated regardless of natural time cues. On the dark side, it's the opposite. Constant night, no sunrise, no morning. People wake by vibration alarms, by scheduled heat cycles, by shifts in artificial lighting. Seasonal affective disorder becomes permanent. Vitamin D deficiency is addressed with supplements, UV therapies, wearable patches. Schools start later. Work shifts adjust to accommodate longer sleep cycles or reversed ones. Some communities sync with other regions across the twilight band, choosing a shared rhythm to feel less isolated in their own sky. Others remain untethered, free-floating in their own loops of rest and activity. Global coordination becomes a new kind of challenge. With no shared daylight, standard time becomes more abstract. Countries disagree on what time it is. Some stick to UTC. Others adopt light-based time. Hours sync to their location on the planet's face, whether sunlit or not. Conferences are scheduled using coordinated cycle blocks, time zones replaced by wake-work sleep units. An email sent from one region arrives at another's midnight, even if it's a bright noon outside the sender's window. International commerce adapts. Trading days decouple from sunrises. Shifts move around the clock. Some businesses operate continuously, with teams rotating every 6 hours. Customer service bots track human sleep cycles to avoid waking users. Digital calendars display personal circadian health scores alongside event reminders. Children grow up learning time as a modular system, no longer morning or afternoon, but phase 1, phase 2, rest zone, sleep interval. Watches are replaced by wearable schedulers that adjust plans based on fatigue, brainwave activity, exposure to light, mood. But not everyone follows the artificial patterns. Some live wild time, untethered to systems, letting the body decide. They wake when they're rested, sleep when they're tired, eat when hungry, work in blocks, not hours. It sounds chaotic, but for many, it brings clarity, especially on the dark side, where the pressure to perform like it's day fades away. Philosophers start to ask new questions. Not, what time is it? But, what is time without rhythm? Is it still linear? Is it useful? Some argue that time is now emotional, felt in moments, in memory, in motion. Others argue for returning to nature's old clocks, the bloom of certain flowers, the cry of migrating birds, the cycles of human biology itself. And inside our bodies, those clocks still tick, though they're confused. The suprachiasmatic nucleus, the brain's master clock, used to reset with every sunrise. Now deprived of natural light cycles, it drifts. Hormone production shifts. Metabolism follows new patterns. Digestion slows at odd hours. Peak focus arrives unexpectedly. Labs run studies on decoupled humans, isolated from external cues. Test subjects settle into internal days that stretch beyond 24 hours. Some land at 25, some at 27, a few reach 32. The body keeps ticking, but it wants to write its own schedule. Now social norms adapt. Meals are no longer tied to specific hours. Restaurants open in 4-hour waves, overlapping with other businesses that work on completely different rotations. Relationships strain and reform across cycle mismatches. New dating apps include phase alignment scores to increase compatibility. Language evolves. Good morning becomes less common, replaced by neutral greetings like, hope you re-rested, or are you in phase right now? Time becomes a personal metric, no longer assumed, always asked. And in the arts, something begins to shift. Films no longer use the sun to show the passage of time. Stories unfold without clear transitions. Novels are written in non-linear fragments to mimic the way memory floats unanchored. Music follows suit. Less emphasis on chorus and verse, more on drift, flow, return. The concept album makes a quiet comeback. Religions adapt. Some continue rituals tied to traditional time, sunrise prayers, fasting cycles, lunar months. Others realign to biological rhythms, encouraging faith practices based on rest, attention, emotional cycles. The Sabbath becomes a personal reset, not a collective pause. And still, we long for rhythm. People build personal routines like scaffolding around their days, not because they need to, but because they want something steady. A walk at the same hour, even if the sky never changes. tea at the same moment in their energy curve, a bedtime song, a stretch, a silence. Because even when the world stops moving, the human mind doesn't. It loops, it wanders, it remembers, and in that remembering we begin to find new kinds of time. The time it takes to forget, the time it takes to heal, the time between changes, the time a story lives inside you before it fades. Not everything needs a clock, but everything eventually needs a rhythm. And while we chase that rhythm, something else is happening. As the planet settles into stillness, the calendar starts to crack. Because if a day no longer means anything, what happens to a year? In a world that no longer turns, you don't wake up to a sunrise. Not anymore. The light doesn't come in through the window. It doesn't climb the wall. It doesn't warm your skin. You don't measure the morning by the way your room brightens, or the way the air smells different, or how birds begin to sing. Because without rotation, the sun doesn't rise. It stays. Wherever you are, whatever part of the planet you live on, the sun is either fixed above you or it's gone completely. And it stays that way for a very long time. Not days, months, half a year of unbroken light, half a year of night. People used to think of the day as the basic unit of time. It was our most intimate loop. Sleep, wake, work, rest. A shape we could trust. But now that shape has changed. The Earth still orbits the sun. That hasn't stopped. It still takes about 365 days to complete one lap. But with the spin gone, that orbit becomes something else entirely. It becomes the only motion that matters. What used to be a simple 24-hour day, light and dark, now unfolds over an entire year. At first, it's hard to notice. The sun seems stuck in the sky, unmoving. But if you measure it carefully over weeks, you begin to see it shift. Not across the sky, but across the horizon, slowly sliding from east to west, following the planet's slow progression around the sun. This is the new day, and it lasts 365 times longer than the one you grew up with. On the sun-facing side of the planet, the light begins softly, a long, slow dawn stretching over weeks. Then it intensifies. The sun climbs so gradually that the change is invisible from one moment to the next. Each week, warmer than the last. Shadows shift by centimeters. Plants track the sun, but not in arcs anymore, just in gentle turns, stretched over seasons. Around month 3, the light reaches its peak. The sun sits almost directly overhead. This is solar noon, and it lasts for weeks. The heat is unrelenting, building strain under continuous expansion and contraction. Water storage becomes critical. Solar power works beautifully, but demand spikes as cooling becomes essential for survival. And still, the sun doesn't move. It stays there, above you, unwavering. A midday that lasts the length of a traditional summer. Days blur into one another. People schedule sleep based on temperature, not light. Work begins in artificial night cycles. Indoor lighting, designed to mimic sunset, simply to give the mind something it recognizes. And then, at last, the sun begins to slide westward. Slowly at first, then more noticeably. Weeks pass, the light softens, shadows grow longer. What once would have been a 10-minute sunset now lasts for over a month. The golden hour becomes a golden season. The world glows amber. The air cools, plants respond. The atmosphere shifts. Animals migrate across the twilight zone, following the shrinking line of comfortable temperatures. Some have adapted. Others simply follow instinct, trusting something ancient, even if it no longer works quite right. And then, just like that, the sun disappears. Not in a flash, but gradually. A sunset that begins in one month and ends in the next. On the far side of the planet, everything has been happening in reverse. While half the Earth baked under a half year of sunlight, the other half sat in darkness. Not dusk, not nightfall, a true unmoving night, the kind where even the stars seem different. Because without rotation, the night sky no longer spins above you. Constellations don't wheel overhead. There's no arc of motion. Instead, the stars hold their positions frozen in place. You could mark them on glass, trace them, they wouldn't move. The moon too behaves differently, its cycle, once regular, now detached from your experience of night. Sometimes it's there for months, sometimes not at all. People stop thinking of it in phases. It becomes an event, a visitor. You track it when it appears, and you miss it when it's gone. In this endless night, the cold deepens steadily. Temperatures fall month by month, surface water freezes, soil hardens, infrastructure shifts from cooling to heating, entire cities become icebound, agriculture halts, food storage becomes a matter of planning, not for winter but for night. Homes are built with thermal mass. Underground facilities grow crops under LED lights, calibrated to mimic the spectrum of midday sun. And in this long night, people turn inward, not just indoors, but mentally. Winter depression becomes year-round for those in the dark half. Calendars split, traditions diverge, birthdays are celebrated according to local sun phases. Someone born in the afternoon on one side of the world might correspond to someone else, midnight on the other. New terms emerge: first light, deep, sunrift, long dusk. You no longer ask, what time is it? You ask, where are you? And beyond that, culture begins to align with orbital motion. School years follow the sun. Industries adjust fiscal quarters to match local light conditions. Festivals are built around sun transitions. Marriages are timed to coincide with the solar equinox. The whole of life shifts toward this new, slow beat. Even science follows. Space agencies launch missions during solar midnight to minimize radiation exposure. Health services structure vaccination cycles and medical care around seasonal immune responses tied to light deprivation or overexposure. Artificial intelligence learns to adapt systems not to global time, but to orbital position. And yet, something about this feels familiar. It's slower, stranger, harder. But at its core, it's still rhythm. Not the tight loop of day and night, but a long breath, an inhale and exhale, stretched across the year. The old rhythms are gone, but we found a new one. And somewhere in that new rhythm, we're not alone. Because not just humans, but animals too are trying to find their place in this new pattern. Animals don't ask questions about time. They don't mark calendars. They don't schedule sleep. They don't care if it's Wednesday. But they know when to wake, when to eat, when to hide, when to run. They know by light, by warmth, by the angle of the sun and the scent of the air. They know by cycles so deeply embedded in their blood that no explanation is needed. The world moves, and so do they. But now the world doesn't move. And for them, the confusion began long before we noticed it ourselves. Some animals respond with silence. Birds that once sang at dawn now fall quiet, not because they're gone, but because dawn never comes. The call and response rituals that mark the beginning of each day are stalled in mid-air. The cues are missing, so they wait. Some never resume the songs, others respond with chaos. Migratory species, tuned to the shifting day length, don't know when to go. Monarch butterflies linger too long. Caribou waits for a signal that never arrives. Whales breach in the wrong season. Some try to leave, flying or swimming or walking toward where they think the rhythm might still exist. Others stay put, waiting for a change that doesn't come. Predators notice it too. Hunting patterns that depended on crepuscular timing, those hours around dawn and dusk, start to fall apart. In the eternal day, prey never settles. In the eternal night, prey never emerges. Ambush predators begin to starve. Those who chase learn to rely on sound, on movement, not on timing. The result is imbalance. Some populations boom, rodents in the dark, insects in the heat. Others crash, reptiles that can't regulate temperature, amphibians that can't find moisture. Species that once coexisted fall out of sync. Food chains twist, ecosystems crack. In the oceans, the disruption is quieter but just as deep. Phytoplankton, which bloom based on sunlight cycles, overgrow in the eternal day and disappear in the night. That shift ripples upward. Fish move to follow the food. Birds follow the fish. Fisheries collapse in regions that once teemed with life. New hotspots emerge unpredictably. Old migration routes become dead zones. Some animals do adapt. Creatures with short generational cycles begin to evolve new habits. Insects adjust breeding times. Rodents shift activity into artificial patterns, active in 6-hour blocks, resting in 8. Cats and dogs, raised in human environments, begin to reflect their owners' strange new rhythms. Sleep, wake, sleep again. In labs, researchers study how animals respond to permanent light or dark. They find that circadian drift is nearly universal. Even in the absence of cues, almost every species keeps some kind of internal beat. Not always 24 hours, sometimes shorter, sometimes longer, but always something, a ticking deep in the cells. And when that rhythm breaks, behavior breaks with it. Aggression increases, reproduction falters, parental care becomes erratic, social structures crumble in pack animals. Some species become more solitary, others become more desperate. There are exceptions. Some deep-sea creatures, long used to darkness and pressure, show little change. Their world never cared about the surface rhythms. Others, bats, moles, cave dwellers, adjust easily. Their clocks were always flexible. They become briefly the best adapted mammals on the planet. Humans start learning from them. Bioengineers study their proteins. Neuroscientists analyze their brains. New treatments emerge. Hormone regulators, light-responsive implants, engineered melatonin variants, not to cure the world, but to help us function in it. People begin to live more like animals themselves, less structured by hour, more attuned to body signals. Hunger, rest, alertness. Routine becomes instinctual, not scheduled. Social interaction shifts from "when's a good time" to "are you in rhythm?" Pets notice too. Dogs sleep in shorter bursts. Cats become more vocal. Parrots stop mimicking doorbells because the doorbell no longer rings at consistent times. Domesticated animals, once in tune with our habits, start to drift away from them or pull us into new ones. And in the wild, entirely new behaviors emerge. Some birds stop migrating entirely. They build permanent nests in the twilight band, where temperatures stay moderate. Others begin to follow human infrastructure, resting in solar-heated buildings, feeding at night markets lit with constant glow. Some species begin to thrive, not in nature, but in the edges of our adaptation. Scientists track it all. They create new categories: light-locked species, phase-shifted populations, drift-adapted ecologies. Entire new fields emerge. Not just chronobiology, but exochronology, the study of life without planetary rotation. And in that study, they start to notice something else. Some animals aren't confused, they're just different. New behaviors are learned, passed on. Wolves that hunt in dark light cycles, birds that time their flights by wind instead of warmth, octopuses that glow in new patterns. It's not that the old world is gone, it's that evolution never needed us to keep it stable. Given new conditions, life keeps going. Not perfectly, but persistently, in ways we don't fully understand and maybe never will. But while we struggle to keep our own structures standing, nature begins quietly rewriting the rules. And in one corner of this still-turning solar system, on a planet no longer spinning, animals are adapting to a new kind of balance. Not in protest, not in confusion, just in motion. And if we listen, really listen, we might learn something from that. Because, in the end, biology doesn't need clocks. It just needs cues, and the planet, though changed, still gives them. You just have to learn how to read them. But while animals move with new rhythms, some things we built can't move at all, and some of them are falling apart. We didn't see it all at once. The day didn't stop spinning and took the world with it in a single moment. The change was slow. Days lengthened, Skies stopped moving, winds settled strangely, but slowly became steadily became obvious. And then it just was. And we did what humans always do when the familiar vanishes. We tried to cope, not in a single way, not in some coordinated utopian effort, but in millions of small, desperate, inventive, stubborn, beautiful, confusing ways. Some people turned inward. They adapted their homes, covered windows in layers of insulation or blackout fabric, depending on which side of the world they lived on. They built rooms around artificial sky panels, screens that shifted through simulated sunsets and clouded noses, just to give the illusion of time passing. Some turned to routine like it was religion. Meals at the same hour, exercises every cycle, schedules laminated and pinned to the wall. Even if the sun didn't move, the body would. Others fled the extremes. Entire populations began to migrate toward the twilight zones, those narrow bands between the scorched and the frozen, where day and night met in something close to balance. Cities rose fast there, temporary at first, tents, portable domes, communal barracks, then permanent arches, vertical farms, habitable towers designed to regulate their own internal weather, light, temperature. Governments tried to follow. Some relocated capitals, others fractured entirely, leaving behind frozen cities and sending representatives into mobile parliaments. International law bent and twisted. New coalitions formed, not always along old political lines, but based on survivability, climate corridors, food-sharing alliances, energy networks. There were disagreements. Who owns the land in the habitable zones? Who gets access to the remaining fresh water? What laws apply when your country no longer has a stable territory? Some conflicts emerged, not world wars, not all at once, but tensions, standoffs, trade restrictions, mass cyber sabotage. A world built on fast, seamless logistics suddenly became slow and territorial again. The flow of goods didn't match the flow of need, and so people started building what they needed themselves. Decentralization became survival. Homes turned into power generators, rooftop solar, wind funnels, thermal batteries. 3D printers re-emerged in popularity, not for toys, but for tools, parts, shelter frames. Local farms reappeared, vertical gardens, mushroom walls, insect nurseries, water recycling systems the size of a dishwasher. Survival wasn't glamorous, but it was often collaborative. Cities became quieter, some were abandoned, others shrank to core neighborhoods. Mass transit fell out of use in places where tracks buckled or froze. Electric bikes, hand-pulled carts, insulated pods. The movement was slow, sometimes erratic, sometimes dangerous. Entire sectors of industry shifted to servicing adaptation. Infrastructure, repairing filtration systems, insulating buildings, updating light calibration schedules. On the social side, people searched for grounding. Some returned to old stories, myths, and folklore that explained a world in crisis. Others wrote new ones. Artists, as they always do, began to reinterpret what existence meant without rhythm, without sunrises, without seasons. Music changed tempo. Books abandoned chapters for seamless flow. Games shifted from fast reaction to immersive drift. Mental health care became a global concern. On the light side, overstimulation and insomnia. On the dark side, fatigue, hopelessness. Therapy changed shape. Fewer couches and notepads, more sensory modulation, communal story sharing, ritualized breaks. People practiced artificial fasting to simulate seasonal shifts. They held silent rituals during long light. They sang into the dark. There were also those who denied it, not out of ignorance, but as a kind of rebellion. Communities formed that lived by the old clock. They kept strict 24-hour cycles, regardless of light. They marked fake sunrises and sunsets. They resisted new language, insisted on morning and night, winter and summer, not out of practicality, but because they couldn't let go or didn't want to. Others embraced the shift with almost religious fervor. Philosophies emerged, built around stillness, groups that saw the stopping of the spin as divine instruction to slow down, to turn inward, to abandon ambition, to listen. The world stopped, they'd say, so we could start hearing ourselves. Not cults, necessarily, just belief systems that made peace with the silence. Education transformed. Children no longer learned geography as fixed. Maps were layered with climate drift, territory zones, orbit phases. Time wasn't taught with hours, but with energy cycles, alertness windows, shared rhythm cues. New math systems were developed to model behavioral drift. New languages dropped time-based metaphors entirely. Don't waste time became don't waste effort. It's getting late became you're fading. And always, behind it all, was technology. Software designed to help people synchronize, work schedules that adapt to circadian data, communication tools that track light exposure, health apps that recommend when to speak or rest based on phase alignment with the people you care about. AI systems became more essential and more invisible. They ran the temperature curves of cities, managed energy flow, predicted microclimate behavior down to the block. Not all-knowing, not perfect, but always watching, always balancing. And yet they too needed parameters we could no longer provide. Models trained on rotation, sunrise, seasonality. Now they learned from new data, from us. We became the pattern. And maybe that was the hardest thing to accept, that the world would no longer guide us, that nothing outside would tell us what to do or when to sleep or where to go. That we would have to decide, and for many that freedom was terrifying. But for others, maybe just a few, it was something else, a beginning. And somewhere in all of it, people started to remember that they never really needed the sun to tell them how to live, only each other. But even in the most adapted places, something else kept catching up, a deep fatigue, not physical, not even emotional, something else. So after all this, could the Earth actually stop spinning? In short, no, not like this, not in a sudden full stop kind of way, not by anything we're likely to witness, not even with our most powerful machines or worst intentions. The Earth spins because it was born spinning. From the moment our planet formed out of clouds of dust and rock, it carried momentum, angular momentum to be precise. The same way a skater spins faster when they pull their arms in, the planet takes shape while rotating, and it hasn't stopped since. There's nothing keeping it spinning, no engine, no motor, just inertia and space. And that's the trick. There's also almost nothing slowing it down over time, a very long time. The spin does change. Tides, pulled by the moon, create friction with the Earth's crust. That friction acts like a brake, tiny, gentle, and constant. Right now, it adds about 1.7 milliseconds to the length of a day every 100 years. Barely enough to notice, but over billions of years, enough to matter. In fact, we have evidence that days used to be shorter. Fossil corals from hundreds of millions of years ago show daily growth rings. Those rings suggest there were once more than 400 days in a year. The planet spun faster. The days were about 21 hours long. The slowdown is real, it's just glacial. And it won't stop completely. At most, over immense timescales, the Earth could become tidally locked, like the moon is to us. It would still orbit the sun, but it would rotate just once per orbit, always showing the same face to the sun. Permanent day on one side, eternal night on the other. That's similar to what we imagined earlier, but it wouldn't happen in our lifetimes, not even in our species' lifetime. Estimates say it could take tens of billions of years, more time than the sun has left, before it swells into a red giant and vaporizes everything. So yes, technically it's possible, but not in a way we'd ever experience, and certainly not in the way we've explored here. This has all been a thought experiment, an exercise in following consequences. If we took one thing, the Earth's rotation, and removed it, what would fall apart? What would adapt? What would we try to fix? What would we try to remember? And what would we quietly let go? It's strange to think that something so constant, something we never even feel, is holding so much together. But that's how the planet works. Its biggest forces are silent. Its most important systems are invisible. Its most fragile balances aren't obvious until they shift. And the Earth spinning beneath your feet, that's one of them. We don't notice it because it's always been there, but without it, almost nothing would feel familiar. So, no, the Earth isn't going to stop spinning, but if it ever did, well, you'd know. And before we bring all of this to a close, there's still one more place to go. One last idea to settle with in the stillness. We've wandered through a world that doesn't turn, a place where the sun no longer rises or sets, where clocks lose their grip, where oceans stall, skies freeze, animals drift, and humans try. We imagined what would fall apart, what might hold together, what we'd miss and what we'd forget, what we'd build and what we'd carry forward, even when nothing outside seemed to move. And now, after all that imagining, after all the strange physics and personal rituals and long, slow days, we're still here, still turning thoughts over, still asking what it means to live on a planet that spins quietly beneath our feet. Because really, the Earth hasn't stopped, not yet, not today, probably not ever, and that means we still have our rhythm, our sunrises, our dusk, our sleep, our wake, our sense of time, as something that happens not just in hours, but in the body, in the way birds start singing before the light reaches the window, in how your thoughts stretch differently depending on whether it's morning or night. We still live inside that rhythm. But maybe, just maybe, by imagining its absence, we understand it better. The quiet miracle of the world, gently spinning us into tomorrow. The background motion that turns chaos into sequence, that gives the oceans their breath, that gives time its shape, that gives us something to dream against. And that's the funny part. In the stillness we imagined, we still found rhythm. We still built stories, we still adapted, we still dreamed. And that's what we do. As long as we're here, as long as something turns out there or in us, we'll keep finding ways to make meaning. So, if the planet ever does stop spinning, you'll know what to do. Until then, you can rest easy. You're still turning. Good night.